A signal. A signal is defined as a physical quantity. It is a physical quantity that varies with the time independent variable or space or any other independent variable. For example, ambient temperature, if you consider, let us record the ambient temperature from morning 6 a.m. to evening 6 p.m. It varies like this. The 12 noon, it is very high. So here, the physical quantity is temperature. Temperature that varies with respect to independent variable time t. This variation of this physical quantity, temperature, is called signal. So how it can be represented? T, that is the temperature, equal to some function of time independent variable t. Why it is called independent variable? You cannot control time. It is varying irrespective of variation of the physical quantity. That's why it is independent variable. Space also independent variable. No one can change it. So a variable which cannot be controlled are called independent variable. So the t equal to f of t. That is temperature equal to function of time. Depends upon the time, it varies. So a signal is defined as a physical quantity that varies with respect to independent variable time t. In this case, signal modeling. The signal can be represented as x of t is a signal. X is dependent variable, t is independent variable. So x is function of t can be written like this. X of t means t is independent variable, x is dependent variable. Here we are representing x as function of t. So this can be written as a is constant sine omega t. Omega also a constant, a also constant. T is independent variable. As t varies, this signal varies. So if we plot this, the signal is looking like this. Sinusoidal signal, a sine omega t. So this is x of t. It is plotted versus time independent variable t. So this is mathematically represented as a sine omega t. That is called signal modeling. Another signal, x of t, can be written as t square. X of t equal to root t. X of t equal to 2t plus 5t square. So as t varies, the value of x changes. So these are all called deterministic signal because they can be expressed mathematically. On the other hand, random signal means it cannot be represented mathematically. For example, the previous, the temperature we have seen, this cannot be represented mathematically. It can be recorded, but cannot be represented mathematically, but can be predicted, but we cannot obtain the exact mathematical model. That's why it is a random signal. It is a random signal which has no mathematical expression means random signal. So the signal which has mathematical expression means that is deterministic signal. Now let us further classify the signal as continuous time signal, discrete time signal, and digital signal. Continuous time signal means the temperature is an example. The sinusoidal wave is an example. Here it is continuously available. This signal is continuously available. At any point of time, the value is available. That's why it is called continuous time signal. On the other hand, the signal is not continuous means For example, I am depositing money every month. 0th month, I deposited some amount. First month, I deposited some amount. Second month, I deposited some amount. Third month, I deposited some amount. So these are all available only at this instant. At the first month, a particular day, first day, let us say. So it is available. On the other day, there is no deposit. So this type of signal is called discrete time signal. This is natural discrete time signal. On the other hand, we can obtain a discrete time signal from continuous time signal. That is also possible. That is also possible. For example, if temperature already we recorded, what is at 6 a.m. what is the temperature? At 7 a.m. what is the temperature? At 8 a.m. what is the temperature? At etc. At 12 noon what is the temperature? At 1 o'clock what is the temperature? 2 o'clock. At 6 o'clock what is the temperature? Every 1 hour the temperature is recorded. Then it is called discrete time signal. These are all values taken from the continuous signal. So we are sampling the signal at every 1 hour. Every 1 hour, we got the signal. So we got the value. And so this signal is temperature is available at n equal to 0, 1, 2, 3, etc. T equal to 1 hour. 1 hour. So when n equal to 0, T of 0. T of 0 is here. T of 0, here it is 1, it is 2. And at T of 0 means at 6 a.m., what is the temperature? At 7 o'clock, what is the temperature? When n equal to 1 and T equal to 1 hour, that's why that is also 1. Therefore, T of 1 equal to what is the temperature? 20.02, 21.03. And T of 3 equal to 22.45, like that. The instant, n is represent the instant at which the sample is made. 0th instant, first instant, second instant, third instant. So n is an integer. T is interval, sampling period or interval. So we are sampling every 1 hour. Therefore, T equal to here, T equal to 1 hour. T equal to 1 hour. Then it is called discrete time signal. These are all called discrete time signal or sampled signal, because we are sampling. It is not naturally discrete signal. It is sampled the continuous time signal. That's why it is called sampled signal or discrete time signal. Now, suppose we are representing the temperature by using only 2 digits. 2 digits only. Then T of 0 equal to what? 20. T of 1 equal to 21. T of 3 equal to 22. Like that we got. Then it is called quantized. Quantized. Here, the minimum value that can be represented by this quantization is 1. Therefore, here the quantization is 1. Quantization is 1. Suppose we want to represent one more decimal place, means T0 equal to 22.4, T1 equal to 20.0, T3 equal to 22, T0 equal to 20.0, and T1 equal to 20.0, T3 equal to 22.4, T3 equal to 22.4. Here, the quantization scale is 0.1. So the smallest value that can be quantized is 0.1. Therefore, the quantization scale is 0.1. In the previously, the minimum lowest value that can be represented in this method is 1. Therefore, quantization scale is 1. Suppose if you want to represent 22.45 means the quantization scale is 0.01 because smallest value that can be represented in that quantization is 0.01. Therefore, we can, if the quantization scale is 0.01 means we can represent T naught equal to 20.02, T1 equal to T of 1 equal to 20.03 and T of 3 equal to 22.45. Like that we can represent. If the quantization scale is 0.01, then it is called digital signal. Quantized discrete time signal is called digital signal. In practice, digital signals are represented mostly by binary signal, zeros and ones. Next one is the very important signal, impulse function. The impulse function is a mathematical signal. Practically, true impulse function won't exist. Why you see? We know that this is a pulse of width delta. Height is 1 by delta. 1 by delta. Energy content is proportional to this area. If this area remains constant, energy remains constant, area is constant. For that, if you decrease delta, what will happen? If you decrease delta, it will be like this. If you further decrease the delta, it will go like this. If you want to decrease this delta, this magnitude m will go on increases. So if delta approaches 0, as it approaches 0, m approaches infinity. M approaches infinity. The limiting value of delta tends to 0. The magnitude reaches infinity. However, the area remains 1. Let us assume that the area of this signal is 1. Area under the signal is 1. Even it approaches 0 and it approaches infinity, the area under this signal is unity. If delta approaches 0 and magnitude tends to infinity, then this pulse function, rectangular pulse function, tends to impulse function. Impulse function. So, impulse function means this width of that pulse tends to 0 and the magnitude tends to infinity, but the energy content is constant. Energy content is constant. Energy content is constant. Remains same. So impulse function means it's the energy content is example, practical example of a impulse function is hammer blow. Hammer blow. If you give me a hammer blow, then that is called the impulse function. Contact duration of that hammer and the surface on which we gave the hammer blow must approach delta t should approach 0. Very, very small. It should be very, very small. Then it becomes impulse function. So practically, this is approaching 0 is not possible. That's why it is a mathematical signal. But negligible time means it can be considered as impulse function. That's why Bruce Lee becomes famous because the duration of contact because of his blow to the other person is very, very, very small. He is giving impulse. He is giving impulse. That's why he became famous. and all his outputs are impulses. That's why it's impulses. Now I think you understand the impulse function. Impulse function means it is a pulse function, rectangular pulse function, whose width tends to zero. That's why its magnitude tends to infinity. However, the energy content in the signal is constant, remains one. How to represent an impulse function? Impulse function a of t equal to minus infinity to plus infinity del of t dt equal to 1. Del of t equal to 1. If you integrate this entire signal from minus infinity to plus infinity, its magnitude remains 1. That is the meaning of this. Here, del of t is the impulse function. It exists only at t equal to 0. So it exists only at t equal to 0. Minus infinity to plus infinity, del of t dt equal to 1 is the mathematical expression of a impulse function, del of t. So its energy content is constant. Energy content is constant. That is very important. So how to represent a delayed impulse function? Delayed impulse function, del of t minus a, del of t minus a. Here also it minus infinity to plus infinity, del of t minus a dt equal to 1. So it will exist when del of this index must be 0. When it will be 0? When t equal to a. When function will exist at when t when this index becomes 0, when t equal to a. Therefore, it is a delayed impulse function. Delayed impulse function. How to represent the delayed impulse function? Impulse function is represented by this. If a impulse function is represented at t equal to 0, this is impulse function represented at t equal to a. Now, let us see the properties of this important impulse function. The first property is minus integral of minus infinity to plus infinity x of t del of t dt equal to x of 0. That is the first property. What is the mathematical expression for impulse function? Minus infinity to plus infinity del of dt equal to 1. Del of t dt equal to 1 and del of t equal to 0 when t is not equal to 0. So this function will exist only at t equal to 0. In other words, the index equal to 0, then only this will exist. That's why the delayed impulse function t minus a will exist when t equal to a. Then only this index becomes 0. So del of t will exist when t equal to 0. First, let us consider this alone. Here, x of t, del of t, if you consider this, let us assume that x of t is exist at t equal to 0. That is important. It is continuous at t equal to 0. Continuous means its value exists at t equal to 0. That is the meaning. So x of t is continuous at t equal to 0. Therefore, its value exists at t equal to 0. But this function will exist only at t equal to 0. Therefore, we can say that otherwise it is 0. Del of t is 0 otherwise. Therefore, instead of writing x of t del of t, we can write x of 0 del of t, we can write. Therefore, the integration becomes, first integration becomes minus infinity to plus infinity. X of t del of t dt equal to, if you substitute this one, why we convert the x of t equal to x of 0? Because del of t exists only at t equal to 0. These two are in product. That's why the x of 0 alone can multiply with the del of t. Therefore, this can be written as minus infinity to plus infinity. X of 0 del of t dt. That is equal to x of 0 is constant. The value of x at a particular value, particular time means it is a constant. That's why we can take that outside is a constant. Suppose I'm having a signal like this. At t equal to 0, what is the value of x? That is called at this point, the value of x equal to x of 0. So it is a constant. That value is constant. That's why we can write this integration can be written as x naught multiplied by minus infinity to plus infinity del of t dt. But this is equal to 1, therefore it is equal to x naught. Therefore, this is the first property of the impulse function. Second property, x of t multiplied by del of t minus t naught equal to x of t naught multiplied by del of t minus t naught. So what is this? This is a delayed impulse function. It will exist like this. This is an impulse function. Impulse function will draw like this. This t, I of t, impulse function. At t equal to t naught, this will exist. It is a delayed impulse function. Delayed impulse function. So this will exist only at t equal to t naught. Here, these two are in product. That's why what the x of t is like this. X of t is like this. It exists from minus infinity to plus infinity. But del of t minus t naught exists only at t equal to t naught. If you multiply these two, all other times impulse function is 0. That's why the value of x at t equal to t naught only will be multiplied with the impulse function. And let us assume that x of t is continuous at x of t is exist or continuous at exist at t equal to t naught. Therefore, we can say that uh, we can say that x of t equal to x of t naught at t equal to t naught. Therefore, we can say that x of t del of t minus t naught equal to x of t naught. All other points, its value exists, but impulse function is not exist. That's why we can say that instead of writing x of t, we can simply write x of t naught, a constant, or the value of x at t naught multiplied by del of t minus t. That is the second property. Now let us see the third property. Third property is what? Integral of minus infinity to plus infinity x of t del of t minus t naught dt equal to x of t naught. X of t naught. To prove this, already we know what is the second property. X of t del of t minus t naught equal to x of t naught multiplied by del of t minus t naught. So we can say that this integration can be written as by using this second property. This integration can be written as minus infinity to plus infinity x of t naught del of t minus t naught dt. That is also equal to x of t naught multiplied by minus infinity to plus infinity del of t minus t naught dt. Let us assume that t minus t naught equal to lambda. So what is dt? dt this is constant. That's why it becomes 0. If you differentiate on both sides, it becomes a t lambda. So this can be written as, now the integration becomes x of t naught. What happens to limit as t tends to minus infinity? Minus infinity minus t naught is minus infinity. That's why lower limit is minus infinity. Upper limit, when t tends to infinity, lambda also tends to infinity, because infinity minus t naught is infinity. Therefore, x of t naught minus infinity to plus infinity, del of del of lambda into d lambda. We know that it's a property of impulse signal equal to 1. Therefore, this is equal to x of t naught is the answer. Therefore, if you multiply by a delayed function of t naught, then its integration is equal to x of t naught. That is the third property. Now, let us see the fourth property. Fourth property, what is the fourth property? Del of at equal to 1 by modulus of a multiplied by del of t. This is the fourth property. To prove this, now let us consider. Now let us consider uh, a function. Uh, third property, minus infinity to plus infinity, x of t multiplied by del of at dt equal to what? Let us assume that a is greater than 0. Case 1. Case 1. Let us assume that a is greater than 1. It is positive. And let us assume that at equal to lambda. Therefore, t equal to lambda by a. Let it be 1. If you differentiate on both sides, dt equal to d lambda divided by a, since a is constant. If you substitute all this here, what you will get? Integral of minus infinity to plus infinity. X of t becomes x of lambda by a multiplied by del of lambda dt equal to d lambda divided by a. This a is constant. If you take this a out, what you will get is, what you will get is, what you will get is integral of 1 by a is taken outside, minus infinity to plus infinity, x of lambda by a is constant, lambda by a, del of lambda d lambda. This function will exist only when lambda equal to 0. Therefore, by using that third property, we can first property, we can write what is first property? The first property is the first property. First property say that minus infinity to plus infinity, x of t del of t dt equal to x of 0, because del of t exists only at t equal to 0. Therefore, here we can say that this will exist only at lambda equal to 0. Therefore, we can say that x of 0 divided by a, both are constant. That's why we are taken outside. That's why minus infinity to plus infinity, x of 0 is taken outside, del of lambda d lambda. This is equal to 1. This is property of impulse function. This is equal to 1. Therefore, this is equal to x of 0 divided by a. Now, now let us consider the case 2. Case 2 is when a is less than 0. So consider the same function, minus infinity to plus infinity, x of t del of at dt equal to what? That is, a is less than 0. That's why on minus will be here. So again, consider at equal to lambda. Therefore, t equal to lambda by a. That is 1. Therefore, dt equal to d lambda divided by a. That is 2. If we substitute all this here, what you will get is minus infinity to plus infinity. X of t equal to lambda by a, del of minus lambda, dt equal to what? D lambda divided by a. If you take that 1 by a outside, 1 by a outside, what you will get? Minus infinity to plus infinity, x of lambda by a. And this is an, this is a, this will exist only when lambda equal to 0. Therefore, there is no meaning of that minus sign. This will exist only when lambda equal to 0. That's why it is an even function. Therefore, del of lambda equal to del of minus lambda. It is an even function. Even function. Therefore, we can write del of lambda d lambda. By using the first property, this will exist only when lambda equal to 0. That's why this becomes x of 0, because it will exist only when lambda equal to 0. Therefore, x of 0 divided by a integral of minus infinity to plus infinity, del of lambda d lambda. This is property of impulse function. This is equal to 1. Therefore, that is equal to x of 0 divided by a. Whether a is positive or negative, we got the x of 0 divided by a. That's why we got positive value only. Therefore, we can conclude that integral of minus infinity to plus infinity x of t del of at and dt equal to 1 by modulus of a. Because why? A is positive or negative, we got positive 1 into x of 0. This is the result we got for both positive and negative. We got the same result. So, what is the result we got? Minus infinity to plus infinity. X of t del of at dt equal to 1 by, always positive we got, therefore modulus of a multiplied by x of 0. Let it be a. We know that from the first property, we know that minus infinity to plus infinity, x of 0, x of t del of t dt equal to x of 0. That is first property. Let it be p. First property. So here we can substitute this first property here. If you substitute this first property by using a and b, right? A, we can say that this we can substitute instead of x naught, we can substitute this. Then what we will get? Minus infinity to plus infinity, x of t del of at dt equal to 1 by modulus of a integral of minus infinity to plus infinity. Instead of x naught, I am substituting the first property, x of t del of t dt. So if we bring this constant inside, then it becomes integral of minus infinity to plus infinity, x of t 1 by modulus of a del of t dt. Now, if we compare left hand side and right hand side, what is the left hand side in the integration? X of t, here also x of t, dt, dt, dt. What is the remaining thing? Del of at equal to del of at, the left hand side, equal to right hand side 1 by modulus of a del of t. This is property 4. That's all. Hence proved. What is property 4? Del of at equal to del of at equal to 1 by modulus of a multiplied by del of t. Hence proved. Now let us see the fifth property. Integral of minus infinity to plus infinity, x of tau del of t minus tau d tau equal to x of t. This is called convolution integral. We will see about this in detail later. Now let us prove this first. To prove this, consider the third property. To prove this, let us consider the third property, minus infinity to plus infinity. X of t, del of t minus t naught dt equal to x of t naught. Replace t by tau and t naught by t. In the third property, this is the third property. Replace this like this. So what you will get? Minus infinity to plus infinity. X of t is replaced by tau. And del of t is replaced by tau minus t naught. T naught is replaced by t. D tau equal to x of t. So if you compare with the fifth property, x of tau we got, d tau we got, x of t we got, except this. Here del of t minus tau, here del of tau minus t. We know that it is an even function, that's why del of tau minus t also equal to del of t minus tau. That's why if you replace this by using that even property, you will get x of tau del of t minus tau d tau equal to x of t. So we got the fifth property. That's that. This is called convolution integral. It has a lot of applications. We'll see later. Elementary continuous time signals. Unit step function. Unit step function is, for example, if you have a battery of 1 volt, it has a switch, a resistor. The value of resistance is R. The switch S is closed when t equal to 0. When t equal to 0, the switch is closed. The voltage across resistance equal to 1 volt. So if you plot this voltage, time versus VR voltage, it will be like this. At t equal to 0, the switch is closed. Therefore, from t equal to 0 up to infinity, or until the switch is opened, the voltage will be 1 volt. This is example for step signal. Step signal. So this is represented by u of t equal to 1 when t is greater than or equal to 0. And u of t equal to 0 when t is less than 0. Step signal is used to test the performance of any system. System means any physical module. If you give any input, it will respond. It will give an output. That is called a system. If you want to test a system whose performance is required, means most of the time either impulse input will be given or step input will be given. Another convenient input is impulse function, because if you give impulse as input, the system will give its mathematical model. That's why it is the advantage of impulse function. So if you give impulse input, the response will be the mathematical model of the system. So to analyze the behavior of the system, we need input signal. One of such elementary continuous time signal is unit step function. Now let us see unit ramp function. That is also another elementary signal. Unit ramp function means its magnitude varies as function of time. Its slope is unity. Its slope is unity, and it can be represented as the signal r of t equal to t when t is greater than or equal to 0, r of t equal to 0 when t is less than 0. This is the mathematical representation of the unit ramp signal. If you represent this in frequency domain, S domain, then we have to take Laplace transform of this. This can be represented as R of S equal to here n equal to 1, power is 1, therefore 1 by S square. 1 by S square is Laplace transform of this ramp signal. For step signal, Laplace transform of this 1 is 1 by S. A constant is 1 by S. So R of U of S equal to 1 by S in Laplace domain. Next elementary signal is parabolic function. Parabolic function is represented like this. It increases like this. It is P of t equal to t square divided by 2. It parabolically increases. Parabolically increases like this. This divided by 2. Why this divided by 2? That we will see now. So its mathematical representation is P of t equal to t square divided by 2 as t is greater than or equal to 0, be equal to 0 for t less than 0. This is the mathematical representation of the unit parabolic function or signal. If you integrate a ramp signal, if you integrate a ramp signal, what is ramp signal? Ramp signal is t. If you integrate that ramp signal, what you will get? You will get t square divided by 2. So that is the one of the reasons why t square by 2 is as assumed as input signal. Another reason is the second one is if you take Laplace transform for this here n equal to 2, n equal to 2. The formula is P of S equal to n factorial divided by S power n plus 1. That is equal to n factorial is 2 factorial is 2 divided by S power 2 plus 1. That is 3. 2 by S cube. Already 1 by 2 is there. These two are getting cancelled. Therefore 1 by S cube. In frequency domain, it will be convenient to represent 1 by S cube. That is another reason why P of t equal to t square divided by 2 is given. In time domain, the parabolic function is t square divided by 2. For frequency domain, P of S equal to 1 by S cube. Rectangular pulse function. This is another fundamental elementary input function. It is looking like this. Magnitude is 1 up to t equal to 0.5. Here t equal to -1. So its magnitude is 1. It is a rectangular pulse. It can be mathematically represented as phi of t equal to 1 for modulus of t is less than or equal to 1 by 2 or 0.5, and pi of t equal to 0 for t modulus of t for t greater than 1 by, or you can write otherwise. So it is a rectangular pulse. Its magnitude is 1. Its magnitude is 1 up to t equal to 0.5 on both sides. So this is the rectangular pulse function. Triangular, its magnitude is 1 to a. So this can be mathematically represented as triangular pulse function. That is equal to 1 minus modulus of t divided by a. When t equal to a, it becomes 1. When t at this point, when t equal to a, this becomes 1. 1 minus 1 equal to 0. When t equal to 0, you will get 1. So it is a triangular function, modulus of t divided by a. As t approaches a, it becomes 0. So the condition is t is modulus of t must be less than or equal to a and equal to 0 otherwise. This is triangular function. Signum function, when t is positive, it's plus 1. When t is negative, here t equal to 0. When t is negative, it is minus 1. Mathematically, it can be represented as a signum function of t equal to 1 minus 1. When t is greater than 0, it is 1. When t is less than 0, it is minus 1. This is called signum function. This is also an elementary input. The next one is sinc function. The sinc function is mathematically represented as sin c, sinc of t equal to sin t upon t. This is the sinc function. It varies from minus infinity to plus infinity. Here, as t tends to infinity, it becomes 0. So at infinity, its magnitude is 0. This is sinusoidal signal, but as time increases, the amplitude of the sinusoidal signal goes on decreases. When t equal to 0, its value is maximum. But limiting case, if we directly put to 0, it becomes infinity. But it is not so as a limiting case because limit t tends to 0, sin t divided by t equal to 1. Because sin 0, 0, t also 0, 0 by 0 form. That's why if you differentiate, you will get cos t divided by 1. So if you substitute, that is equal to 0, t equal to 0, you will get 1. So as a limiting case, its value is 1. Then it gradually decreases and finally it goes to 0. On both sides, it will be like that. This is called the sinc function. Sinc function. Next, this is mathematically represented as sinc c of t equal to sin t divided by t, as t varies from minus infinity to plus infinity. Gaussian function is looking like this. The Gaussian function is represented by g of t equal to Gaussian function equal to e power minus a t square. minus a t square. Here also the t varies from minus infinity to plus infinity. E power minus a t square. This function is widely used in probability theory. This is another elementary function, Gaussian function. Another input is sinusoidal input. Sinusoidal input is it varies, it starts from 0, it oscillates then. Here it will be like this. Sinusoidal function. It is mathematically represented as x of t equal to a sine omega t plus theta. Theta is the phase shift. Theta is the phase shift. Here no phase shift. In this case, theta equals 0. Omega t plus theta. A is the magnitude A equal to 1. So if it is 1 means its maximum amplitude is 1, then minus 1. If A is 1, otherwise A value will be the amplitude, the signal. This is sinusoidal signal. A sine omega t plus theta, where theta is the phase shift. Phase shift. Phase shift means suppose here theta equal to some 30-degree means there will be a plus 30 means it comes like this. This is theta equal to 30-degree. Minus 30-degree means it will come like this. Here there will be a delay in the signal 30-degree. Plus theta means it advances. So this is phase shift. In this case, here there is no phase shift at all. No phase shift at all. That's why theta, in this case, theta equal to 0. Here theta equal to 30 plus 30. Here theta equal to minus 30-degree. So this is sinusoidal signal. Next elementary signal is real exponential. That is x of t equal to e power at. The a value may be a equal to 0, or a may be greater than 0, or a may be less than 0. Less than 0. If a equal to 0 means e power 0 equal to 1, therefore it is nothing but a signal is always 1. Always 1. If a is greater than 0, what will happen? Exponentially increases. Exponentially increases. That is e power at for a greater than 0. If it is a is less than 0, then this is e power minus at. That is a is less than 0. So these are all real exponential signals. When a is 0, you will get always amplitude equal to 1. A is greater than 0, it is exponentially increasing. A is less than 0, then exponentially decreasing. This is exponentially decreasing function. This is exponentially increasing function. So next one is complex exponential. That is x of t equal to e power st. But s equal to what? Sigma plus j omega. And e power, so that's why it can be written as e power sigma plus j omega multiplied by t, or e power sigma t plus j omega t. If omega equal to 0, then it becomes real exponential signal, as we have seen earlier. When sigma equal to 0, you will get amplitude 1. When sigma is greater than 0, then you will get exponentially increasing function. If it is less than 0, you will get exponentially decreasing function. So when omega equal to 0, it becomes a real exponential signal. If omega is not equal to 0, we know that e power j omega t equal to cos omega t plus j sin omega t. That's why x of t becomes x of t equal to e power sigma t multiplied by cos omega t plus j sin omega t. J sin omega t. J sin omega t you get. So here, if omega is less than 0 and sigma is less than 0 and omega is constant means what you will get is you will get exponentially decreasing sinusoid. Exponentially decreasing sinusoid you will get. Sigma is greater than 0 and sigma is constant means what you will get is exponentially it go on increases. Signal you will get exponentially increasing signal you will get. That is sigma is greater than 0. This is for sigma less than 0. If sigma is 0, then what you will get? You will get a sinusoidal signal. Sinusoidal signal. If sigma equal to 0, you will get sinusoidal. So these are the elementary signals that we have seen so far. And sigma is 0 and both are 0. What you will get? So e power 0 plus 0, 0. E power 0 equal to 1. So you will get a constant 1 signal. So all possibilities that we have seen. That's all about various type of elementary signals. Here also the integral is involved with the impulse function. Impulse function, a delayed impulse function, delayed impulse function. Again, we have to use the same property of impulse function, that is x of t del of t minus t naught dt equal to x of t naught. Here, x of t equal to t square. X of t equal to t square. Delay t naught equal to and t naught equal to 3. Therefore, the answer is t square, where t equal to 3. Therefore, 3 square equal to 9. 9 is the answer. Evaluate the following integral. This integral involves impulse function. Del of t minus 10. Impulse function. It is a delayed impulse function. Delayed impulse function. This is x of t. So we know one of the properties of impulse function is minus infinity to infinity x of t del of t minus t naught dt equal to x of t naught. This is one of the properties of impulse function that we know. By using that, we can solve this. Here, t naught equal to 10 because delay is 10 seconds. And x of t equal to e power minus alpha t square. Therefore, the answer is x of t naught. Therefore, e power minus alpha t square, where t equal to 10. Therefore, e power minus alpha 10 square, that is equal to e power minus 100 alpha. That's all. Basic operations on signals. What are the basic operations that one can do on a signal? Are time shifting. It means delaying a signal or advancing a signal. That is called time shifting. Time reversal. Time reversal Actually, this is mathematically possible. Suppose something is happened here, means if you reverse this like this with respect to time axis, finding the mirror image of this is called time reversal. That is a mathematical operation. Time scaling. So the rate of the signal can be, that is, speed of the signal can be increased or decreased. That is called time scale. Speed of the signal, speed of the signal can be increased or decreased. That's called time scaling. Amplitude scaling, that is increasing the uh, amplitude of the signal. Suppose this is the signal means if you amplify this, it will be like this. So this is called amplitude scaling. Signal multiplier. Two signals can be multiplied together. X1 of t and x2 of t are multiplied together. That is called a signal multiplication. Addition. Similarly, we can add two signals. Um, say x1 of t and x2 of t can be added together. That is called a signal addition. So these are the operations we can do on signal. Let us see one by one. Time shifting. Suppose I'm having a signal. Um, this is the signal that exists from T1 to T2, x of t minus t, t seconds. In this case, if t is positive, then it is called delay, delayed signal. If t is positive, x of t minus of minus t, that is equal to x of t plus t. That is, t is negative. If t is negative, in that case, it is advanced. So let us see both one by one. First, delay. Delay means what will happen? The same signal, initially it started at T1. This is T1 plus T. So instead of starting at T1, it started at T1 plus T and ends at T2 plus T. This is x of t. This is delayed. This is x of, the signal is x of t minus tau. T is positive. If t is negative, what will happen? That we will see now. T is negative means you will get x of t plus t. So in that case, initially it started at T1, ends at T2. Now the signal is advanced. If this is T1 minus T. This is T2 minus T. So it starts earlier and ends earlier. This is called advanced signal. That is x of, this is x of t plus t. Signal is advanced. So this is called time shifting. Time shifting. This is one of the basic operations on signal. Time reversal is a mathematical operation on a signal. For example, I'm having a signal like this. It has x of t. This is x of t. It starts at 0, 1, 2, 3. Finding x of minus t is called the time reversal. It is nothing but the mirror image of is nothing but the mirror image of the signal about y-axis. That is called x of minus t. So mirror image of the signal about y-axis is called time reversal. Combination of time reversal and time shifting. Time shifting will be used in many places. Now let us see the combination of time reversal and time shifting. Suppose I want to shift, delay the x of t by t, or 2 seconds, let us say. What is x of t minus 2? Here, delay of 2 seconds. That's why the signal will start, instead of 0, it will start at 2, end at 5. This is x of t minus 2. On the other hand, what is x of minus t plus 2? What is x of time reversed? X of minus t plus 2. This can be written as x of minus of t minus 2. Minus sign. This minus sign indicates time reversed. Time reversed. This minus, this 2 indicates delay. Therefore, what you will get here is, here also there will be a delay. So instead of starting at minus 3, it will start at minus 1. It will start at minus 1. Minus 1, 0. It will end at instead of 0, it will end at 2. This is what this is x of minus t plus 2. So to avoid confusion, we are writing this as x of minus of t minus 2. So you won't get any confusion, because this minus sign is to indicate the time reversal. This minus 2 indicates the delay. What is x of t plus 2? Advanced. X of t plus 2 means it starts at minus 2. This is x of t plus 2. So it is started at minus 2 instead of 0. So the x of t, this is x of t plus 2. What is x of minus t minus 2? This can be written as x of minus of t plus 2. This minus indicates time reversal. Time reversal. And this 2 indicates advancement. So time reversed signal is this x of minus t. It has to be advanced. Advanced means instead of starting minus 3, it will start at minus 5. Advanced. So minus 5, and it will end at minus 2. Minus 5, minus 2. Instead of 0, it will end at minus 2. So this is x of minus t minus 2. That's all. So this is to understand time reversal. a combination of time reversal and time shifting. Combination of time reversal and time shifting. Now let us see some sums so that we can clearly understand this time reversal and the time shifting. To understand the time reversal and time shifting more, let us do some problems. Sketch the following signal. U of minus t plus 1. We know that u of t is a step function. How it looks like, it will be like this. It goes up to infinity. Time goes up to infinity. Its magnitude is 1. That is u of t. What is u of minus t? Time reversal. That is time reversal. That is 1 up to minus infinity. This is time u of minus t. Just a mirror image about y-axis. That is u of minus t. Now we have to find u of minus t plus 1. For that, let us do one thing. Let us take that minus sign side t minus 1. So this minus sign indicates that time reversal. Time reversal. And this minus sign indicates the delay. Therefore, time already reversed. Now we have to delay. Delay means 1 second delay. 1 second delay means minus infinity plus 1. Minus infinity plus delay 1. So if you add minus infinity plus 1 equal to minus infinity. That's why there is no change in the initial. But the end, where it ends, at the end, it ends at 0. If a signal is delayed, means it ends with a delay. Therefore, it will end at 1. Therefore, this minus 1 indicates delay. No, that's why it will this will end at 1, not at 0. Therefore, the signal will be looking like this. This is u of minus t plus 1. Now let us see one more. Fetch the following signal. Minus 2u of t minus 1. T minus 1. U of t we know. A step function. This is u of t. This is u of t. What is u of 2t minus 2t? U of minus 2t means its magnitude is minus 2. Minus 2 u of t. This is minus 2 u of t. What is minus 2 u of t minus 1? Delay by 1 second. So here it starts at 0, but it will start at 1 instead of 0. It will start at 1. This is 0. It starts at 1. Magnitude here is minus 2. That is, this signal is minus 2u t minus 1. Now let us see one more sum. 3r sketch 3r of t minus 1. R of t minus 1. R means 3r of t minus 1. It is a ramp function whose slope is 1, unity. Unity means if you take 1 here also it will be 1. Therefore, slope is equal to 1. Slope equal to 1. But here 3r, that's why slope must be 3. So convert like this. 1, 2, 3. 3, 1. So slope is 3. So now we got the signal is 3 r of t. But with a delay of 1 second, therefore, instead of starting at 0, it should start at 1. Slope is 3 r of t minus 1. Start at 1 instead of 0. So this is 3 r t minus 1. That's all. Then fourth sum. Sketch 2 r of t minus 2 r of t. What is that? R of t is what? R of t is unit slope. Slope equal to 1. It means here 1 means here also 1. That is slope 1. 2r means slope is 2. 1, 2. If we draw here, it will be 1. Then slope is 2. 2r we got. Minus 2r means it will be inverted. Mirror image about x-axis, that is minus. So what you will get is this is minus 2 r of t. Mirror in this is r of 2 r of t, 2 r of t. This is minus 2 r of. This is minus 2 r of. This is 2 r of t. If you invert, this is minus 2 r of t. Mirror image about x-axis is minus. Magnitude minus. So magnitude minus means we have to take mirror image about x-axis. Time reversal means you have to take mirror image about y-axis. There is the difference. Sketch fifth one. Sketch r minus t plus 2. R of t is what? Unit slopes in ramp is in. Here 1 means here also 1. Therefore, the slope is 1. So time reversal, r of minus t. So r of minus t means mirror image about y-axis. This is slope 1, but r of minus t we got. Now we have to find r of minus t plus 2. We'll write in the other way. R of minus of t minus 2. This minus indicates that the time reversal. Time reversal. This minus 2 indicates delay. Delay. Therefore, it starts at 0. Delay means it should start at 2 instead of 0. So now this is r of minus t. If it starts at minus 2, sorry, plus 2, then it is called r of minus t plus 2. This is also equal to r of minus of t minus 2. This minus sign for time reversal, this minus sign for delay. This is for time reversal. Time reversal. That's all. Now let us find another signal we'll draw. Phi of t plus 3. Phi of t we know, rectangular signal. It looks like this. Magnitude is unity. Both sides t equal to 0.5 or 1/2. Here also t equal to minus 0.5 equal to minus 1/2. So here t plus 3 Plus 3 means advanced. So where it starts at a 0.5. So it will be advanced means it should move to its left. So what we have to do, instead of starting at 0.5, instead of starting at 0.5, this is 1, 2, 3, 3.5. It should start at 3.5. Here where it ends 0.5. This side we have to move 3 times. If you move 3 times, it ends at 2.5. Therefore, it will be like 2.5 minus 2.5. This is pi of t plus 3. So time shifting. Here, time shifting to the left because it is advanced. Plus, that's why it is advanced. So advanced by left 3 units. That's all. Sketch the following signal. U of n plus 2 digital signal minus U of n minus 3. So we have to take these two signals and we have to subtract. What is U of t we know? Continuous time. That is, we will put like this. But the U of n is digital signal. It is available at every sampling instant. It will be like this. Its magnitude will be 1, 0, 1, 2, 3, etc. Like that it is. U of n plus 2. Plus means we know that it is advanced. Advanced means it starts earlier. It starts earlier. So it starts at instead of 0, it starts at minus 2, 1, 0, minus 1, 0. So it starts at minus 2. 1, 2, 3, etc. It goes on up to infinity. N tends to U of n plus 2 we got. Now we have to obtain U of n minus 3. This minus indicates that it is a delay. That's why it starts at, instead of 0, it starts at 3. Starts at 3. 4, 5, 6, etc. Here it starts at minus 2. Here it starts at 3. So from 3 onwards, both signal has signal up to infinity. So up to infinity, both has signal from 3 to infinity. Its magnitude is here 1, here also 1. So if you subtract U of n minus 3 from n plus 2, what will happen? If they are equal, they are getting cancelled. Because if you subtract, this is also 1, this is also 1. Let us assume that this is 10, this is 10. This is also 1, this is also 1, getting cancelled. 11, this is 1, this is 1, getting cancelled. Up to infinity, it is getting cancelled. From 3 onwards. So before 3, whatever the signal available here will be there. From minus 2 to 3, minus 2 to 2 is available. So the answer is, you will get at minus 2 one signal, at minus 1 one signal, at 0 you will get one signal, at 1 you will get one signal, at 2 you will get one. That's all. It's all other values are getting cancelled. Let us draw one more sum. Let us solve. Sketch the signal u of minus n plus 2 multiplied by u of n. U of n we know. It starts from, it is like at 0 it starts. 1, one signal, 2, one signal, 3, one signal, etc. up to infinity is, that is u of n. U of minus n plus 2 means u of minus n is mirror image about y-axis minus n. U of minus n, that is mirror image about 1. This is 0, 1, minus 1, minus 2, minus 3, etc. up to minus infinity. There is no signal the right hand side. So everything becomes left. Minus n plus 2 means u of minus n plus 2 means it can be written as u of minus of n minus 2. This minus sign is time reversal. Time reversal. This is delay. This is delay. So already we got time reversal. Now we have to make a delay of minus 2. Delay of minus 2 means it should shift, minus infinity should shift 2 points to its right. So minus infinity plus 2 equal to minus infinity. Minus infinity plus 2 equal to minus infinity. That's why no change in the this side. Here it ends at 0. If starting as delay means end also will having delay. It ends at 0. Some delay means where it will end. It will end at 2. End at 2. Now this what is u of minus n plus 2, that is equal to u of minus of n minus 2. So it will be like this. It ends at 2. Ends at 2. That's all. So now you have to multiply this with the u of n. We'll write the u of n in the bottom. 0, 1, 2, 3, 4, 5, 6, etc. If you multiply these two, here all are 0. To the left of 0, u of n is 0. U of n is 0 to its left. To right, all will be 1, 1, 1, 1 at every sampling instant. U of minus n plus 2, if you consider left all 1, right side only 2 elements. 0, 1, 2 only we have 1. So if you multiply this and this 1 and 1, you will get a 1. This 1 and 1, if you multiply, you will get 1. This 1 and 1, if you multiply, you will get 1. At 3, here you will have 1. Here you are having 0. So 1 multiplied by 0, 0. 4, 1 multiplied by 0, 0, 0. That's why it won't exist. Here, if you consider left hand side, u of minus n plus 2 having all negative values. 1, 1, 1, 1. Up to infinity, minus infinity. Up to minus infinity. But here all 0. That's why everything is 0, 0, 0, 0. Only this 3, 1 will be there. That's all about u of minus n plus 2 multiplied by u of. It's an amplitude scale. Amplitude scaling means either you have to amplify the signal, or attenuate the signal. For example,
it has an amplitude of 1. Suppose this is x of t. If we amplify this, its amplitude is increased to 2. This is called amplitude scale. This is y of t is scaled by 2 times. We can attenuate x of t, then we like this. Its amplitude is reduced to 0.5. Amplitude is reduced. In that case, y of t equal to 0.5 times x of t. So either amplifying the amplitude or attenuating the amplitude is called amplitude scaling. The case of digital signal will be like this. 1, 2, its magnitude is 2. Then sample instant 1, 2, sample instant 1 and is 0.5. So if you 2 times amplification, it's order is 40. Here you will get 1. Here you will get 2. Here you will get 4, 0, 1. Y of n equal to 2 times x of n. Similarly, we can attenuate this. Then what you will get is at 0, you will get the magnitude of 0.5. At 1, 0.5 is 0.25. At 1, you will get 0.5 amplitude. At 2, you will get 1. So y of n in that case equal to 0.5 times x of. So that's called amplitude scaling. Time scaling. Time scaling. Time scaling means let us consider this x of t. X of t equal to minus 1. To minus 1, its magnitude is 1. At 0, its magnitude is 1. At 1, its magnitude is 2. At 2 again, its magnitude is 1. At 3 also, its magnitude is 1. This is the signal x of t. Time scaling means the rate at which it varies. The rate at which it varies can be increased or decreased. If you compress the signal from minus 1 to 3 is reduced to minus 0.5 to 1.5 means the signal is compressed. So y of t equal to x of 2t means will be compressed from minus 1 to 3 to minus 0.5 to 1.5. So y of t equal to x of 2t. So we are compressing the time axis by 2 times. So it varies from minus 1 to 3 means it is varies here in y. It varies from minus 0.5 to 1.5. So in x of 1 equal to 1, x of 0 equal to 1, x of 1 equal to 2, x of 2 equal to 1, x of 3 equal to 1. This is given. But this is reduced to y of 1 is 0.5, compressed. The speed of the signal is increased. That's why compressed. Y of minus 0.5 This is 0 is remains 0. 1 is reduced to 0.5 because 2 times compressed. So y of 1, 2 becomes 1 equal to y of 3. Y of 0.5 equal to x of 2 times x of minus 1 equal to 1. Y of 0 equal to x of 0, that is 1. X of 2 times 1, x of 2. Y of 1, that is x of 2 equal to, again, x of 2 equal to 1. X of y of 1.5, that is x of 3 equal to, again, 1. So if you plot this, what you will get, y of 0.5, this is 0, time axis, y of t we have to draw. Here it is minus 0.5, 0, then plus 0.5, plus 0.5, 1, 1. Here at the point minus 0.5, its value magnitude is 1. At the 0, its magnitude again 1. At 1, it is 2. Sorry, at 0.5, it is 2. At 1, again, it becomes 1. At 1.5, it remains 1. So, its width is reduced from 1 to 3 to minus 1 to 3 to minus 0.5 to 1.5. This is called the time scale. Suppose y of t equal to x of t by 2 means the signal is slowed down. The speed of the signal is reduced, enlarged. The speed is reduced, means time axis is enlarged. In that case, x of 1 is 1, x of 0 is 1. So here it is enlarged. That's why you will get y of 1 means it becomes 2. Y of 0 is 0. Y of 1 becomes 2. Y of 2 becomes 4. Y of 3 becomes 6. So this is x of 1. This is x of 0. This is x of 1. This is x of 2. This is x of 3. This is equal to 1, 1, 2, 1, and again. So if you draw this, what you will get? This is 0. The at 2 it is 1. Up to y of 0 it is 1. From 2 to 0 it is 1. Then at 2 it is increased to 2. This is 2. Then at 4, to 4 again it reduced to 0, 1. At 6, up to 6 it is 1. So this here in x it varies from minus 1 to 3. Y it varies from minus 2 to minus 2 to minus 2 to 6. So it is enlarged. the signal is slowed down. It slowly varies. Here it varies very fast. The signal becomes very fast. Here in this case. Find x of t minus 2 for the given x of t. X of t is given. It starts at minus 1, end at 2. This is the signal. For the signal, we have to find x of t minus 2. This minus 2 indicates that delay. Delay means it starts at minus 1 means 2 units of time delay means it will start at 1. So a delayed. So what is the signal? 2 at 1 it will start up to it will start like this. Then suddenly it raises to 2. We keep to the same value of 2, 3. Then goes this way 4. So this is minus delay of 2 units of time. That's all. X of t minus. To find x of 2t plus 3 for a given x of t. X of t is given. We have to find x of 2t plus 3. Here, time scaled by 2 times. This 2 indicates that time scale. Time scaling. This plus indicates that advancement. Delay or advancement. But in this case, since it is positive, that's why it is advancement. But if you get like this, we cannot perform any shifting of signal first. We have to do time scaling first. So we have to do time scale first, always time scale first. Then we have to do delay or advancement. We have to do. In this case, advancement. That's why first we have to do the time scale. That's why if you do time scale for this first means for this 3 also we have to do the time scaling. That's why we have to take that 2 outside. So y of t equal to x of 2t plus 3 by 2. Then it's okay. First we have to do the time scaling of 2. Then we have to do advancement of 3 by 2 units of time. So let us find y of t equal to 2t first. X of 2t first. X of 2t first. To find that, we have to take the for all coordinates of y. What are the x coordinates here to draw this signal? X of minus 1, 0, 1, 2. These are the coordinates we require. So y of minus 1, y of 0, y of, we have to take y of 1 and y of 2 we have to. So we have to compress this signal. 2t means, x of 2t means we have to compress. So to compress, we have to divide this by 2. So 2 times we have to compress. That's why divide by 2. That's why what we will get is y of minus 0.5, y of 0, y of 0.5, and it is equal to y of again 2 by 2, that is 1. So we know that y of t equal to x of 2t. 2 times means you will get the same coordinate. At this coordinate, the value of x is x of
1 equal to y of t equal to x of 2t. 2 times minus 0.5 equal to x of minus 1. Here the value is 0. Then x of 0 that is equal to x of 2t. 2 times 0 is 0. That is here it is a two-valued function. Initially it is 1, finally it is 2. Therefore 1/2. Y of 0.5 means 2 times means x of 1. Here again two-valued function. Initially it is 2, then it becomes 1. At y of 1 means x of 2 because y equal to x of 2t. That is equal to, again it is two-valued function. Initially it is 1, finally it is 0. So now we have to draw the waveform. To draw the waveform, what are the coordinates we have to take? Y of minus 0.5, then 0, then plus 0.5, and then 1. So these are all we have to take. Y value 1, this is 2. Initially it is 0. We have to mark this point. Then it is 1. Then it becomes 2. Then at point y of 0.5, it is initially it is 2. Then it becomes 1. Y of 0.1, initially it is 1. Then it becomes 0. So we got the waveform. This is what x of 2t we got. Now we have to shift by advance by 3 by 2 times. Advance by 2 times. What we have to find? The x of 2 times t plus 3 by 2 we have to find. Because we took the 2 outside, that's why 3 by 2. If you advance this by 3 by 2 times, 1.5 times. 1.5 time means 1 time means 0.5, 1.5. So we have to shift it to 2, minus 2. So this should be shifted to, this minus 0.5 should be shifted to minus 0.5 should be shifted to minus 2. 0 should be shifted to minus 1.5. And 0.5 should be shifted to 1, minus 1. And 1 should be shifted to minus 0.5. So we have to start at 2. And next point is minus 1.5. Minus 1.5. Next point is minus 1. Next point is minus 0.5. Minus 0.5. So here this is 1, this is 2. This is x of 2t plus 3. This is the answer. Find x of 3 by 2t. Find x of t is given. X of t is given. Find x of 3t by 2. So it means time scale by 3 by 2. So 3 by 2 is 1.5. 1.5. So we have to compress. It is greater than 1. That's why we have to compress 3 by 2. So what we have to do is, what are the coordinates? Minus 1, 0, 1, and 2. So y of minus 1 divided by 3 by 2. 3 by 2. that is equal to y of minus 2 by 3. Y of 0 divided by 3 by 2. That is equal to y of 0. Y of 1 divided by 3 by 2. That is equal to y of 2 by 3. Y of 2 divided by 3 by 2. That is equal to y of 4 by 3. So y of minus 2 by 3 means that is x of 3 by 2 times this. That's why you will get x of minus 1. Here x of 0 you will get. Here x of, because y of t equal to what we have to find, x of 3t by 2. So if you multiply by this inverse, you will get this. 2 by 3, we have to multiply, so you will get 1. Here you will get x of 2. So here, what is the value? Here 0. Coordinate. Y coordinate is 0. Here y coordinate is, initially it is 1. Later it becomes 2. Two-valued function. Two-valued function. Here also, at 1 also, two-valued function. Initially it is 2, then it becomes 1. Here also two-valued function. Initially it is 1. Initially it is 1. Finally it becomes 0. So now let us draw the waveform. What are the y values? Y minus 2 by 3. This is minus 2 by 3. Then 0. Then plus 2 by 3. And 4 by 3. This is 4 by 3. So initially it is 0 and this is 1 and this is 2. It goes this way. Initially it is 1, then 2. Then it becomes 2. Initially it is 2, then it becomes 1 at 2 by 3. Initially it is at 4 by 3, it is 1, then it becomes 0. That's all. This is compressed by 3 by 2. Find x of minus t plus 1. For that, y of t equal to x of minus t plus 1. So this minus sign indicates that time reversal. Time reversal. This plus 1 indicates that delay. So let us write in correct form. Y of t equal to x of minus, if we take outside, you will get t minus 1. Minus 1. So this minus sign indicates time reversal. Time reversal. And this minus indicates that time delay. Minus sign, that's why time delay. So first we have to do time reversal or time scaling. Scaling. Time reversal or time scaling. Next, what we have to do is delay or advancement. Advancement. So first let us do time reversal. So if you do the time reversal, what you will get is one, and this goes to 2, then it comes up to -1, -2. Now it's time reversed. This is x of minus t. Now we have to delay this by one unit of time. That's why if you two, instead of starting at -2, it should start at -1. Now delay by minus sign. That's why delay by 1 unit of time or 1 second. So it starts at -1. Again starts at -1, then increases to 2 and remains at 2 up to 1, 0, 1. Here it increases to 0 to 2. So it ends at 1. So delay by 1 unit means it should end at 2. It starts at -2, delay by 1 unit. That's why it starts at -1. Starts at -1, ends at 2. This is the required signal. This is x of minus t plus 1. Sketch the following signal. The first one is u of t minus u of t minus 2. How to sketch this signal? For that, what is u of t? U of t is a step signal. It goes up to t tends to infinity. Its magnitude is 1. This is u of t. What is u of t minus 2? This minus indicates the delay. So delayed step function. So it starts at 2, 1. Magnitude is 1. Again, it goes up to infinity. T goes to infinity. Till then, its value is 1. So from this first signal, we have to subtract the second signal. So after 2, if you see, after 2, both 1 minus 1, 0. Therefore, after 2, it will be 0. Before that, here 1, here 0. 1 minus 0 is 1. Therefore, this is the answer. This is u of t minus u of t minus 2. Yeah. A rectangular pulse we got. Rectangular pulse we got. Sketch the following signal. Sketch the following signal. Pi of t minus 1 by 2. T minus 1 by 2. We know that pi is a signal which is spread on both sides up to 0.5 t. So this minus sign indicates the delay. Delay of 0.5 means this will shift to 0. Therefore, the signal is again a rectangular pulse, 0 to. This also will shift to 1. This also will shift to 1. So 0 to 1, a rectangular pulse, 0 to 1. Again, we got the same result as we got in the first sum. Rectangular pulse. This is pi of t minus 1 by 2. T minus 1 by 2. Next, third sum. For t minus 1 divided by 2 plus pi of t minus 1. T minus 1, that is the third sum. So this can be written as, first let us draw this pi of 1 by 2 we can take outside, t minus 1. This is time scale. So what is pi of t is this. This is pi phi of t minus 0.5 plus 0. So 1 by 2 means y. First, let us find y of t equal to pi of 1 by 2 t. First, let us find. This is 1 by 2 is time scale. This minus 1 is delay. So first, let us do the time scale. That's why 1 by 2 t is taken. So y of only two coordinates. Only two coordinates here, minus 0.5 and plus 0.5. So y of minus 0.5 divided by time scale is again 0.5. 0.5, that is equal to y of minus 1. Y of another coordinate 0.5 time scaled by 1 by 2, that is 0.5 divided by 0.5, that is equal to y of 1. That is equal to pi of 1 by 2 t. T is 1. So 1 multiplication of by 2 minus 0.5. Magnitude is 1. That is pi of 0.5. That is equal to 1. Therefore, the signal, y signal is varies from minus 1 to plus 1. That is pi of minus 0.5 t. 0.5 t. Now we need a delay. Delay of 1 means this will move here and this will move to 2. Therefore, now we will get 1 to 2 magnitude of 1. Magnitude of. We have to add with this signal. What is this? Pi of t minus 1. Delay of 1. So what is pi of t? This is pi of t. This is pi of t. This is pi of t. If we give a delay of 1 means you have to shift to minus 0.5 to plus 0.1, 1 unit time of delay. Therefore, it starts here and the end at starts at 0.1 plus 1, 1 point, end at 1 point. This is pi of t minus 1, t minus 1. We have to add, this is pi of 1 by 2 t minus 1 by 2. We got first part, we got. What is second part? Second part is starts at 0.5, end at 1 point. If you add these two together, at 0 only this signal is there. Up to 1.5, both signals are there. Up to 2, only one signal. After that, no signal. So if you add these two together, what you will get is up to 0.5, 1 magnitude is 1. From 0.5 to 1.5, both, that's why it will be doubled. This is 2, this is 1. After 1.5, this alone again reduced and up to 2. So here magnitude is 2, here magnitude is 1. R of t, this is up to 1. Sketch the signal R of t. Answer for minus 2 R of t minus 1 plus R of R minus 2. R means a ramp signal. Ramp signal. Ramp, its slope is 1. Here ramp of slope 2, ramp of slope 1. If you add all these together, you will get a triangular signal. Triangular signal, that we will see how. First, let us draw all signals one by one. R of t means its slope is 1. 1, 1. Slope is, its slope is 1. 2 R t minus 1. Minus 2. So, amplitude downward with a delay of 1 second. So it starts here, but slope is minus 2 times. So this is 1, this is 2. With this 1, this is 2. Slope is, for this the slope is, height is 2, width is 1. Time axis 1 unit, y-axis is 2 units. 2 by 1 is slope is 2. Slope minus 2. Slope minus 2 we got. The third signal is r of t, delay of 2 seconds. That's why this is parallel to this. Parallel to this. That's all. So now if you add all these together, what will we get? So we have to add point by point. Time axis, we have to take every point and we have to add vertically. If you see at 0, 0. So the added signal is this. Added signal is at 0, 0 only. At 1, up to 1, this is the only signal. That's why up to 1, this will increase like this. So its magnitude is 1. That's all. After 1, what happens? It increases at the rate of a slope of 1, decreases at the slope of 2. Means one slope getting cancelled. Decreasing with a slope of -2, increasing with a slope of 1 from this point onwards. So one slope getting cancelled. So it will decrease at the rate of one slope. So it will go down up to 2 with a slope of -1. Its slope is -1. Its slope is +1. So increasing, then decreasing. Then from 2 onwards, all the 3 signals are there. This is slope 1. This is also slope 1. Slope 1. So totally 2 slope 1 and decreasing with the slope 2. So if you add all together, it becomes 0. From 2 onwards, the magnitude is 0, remains 0. So slope 1, here slope 2. That's why 1 plus 1 minus 2 equal to 0. Total increase is 0. That's why it is a triangular pulse. Triangular pulse. So to sketch the following signal. R of t multiplied by u of t 2 minus t. R of t, you know, R of t is a ramp signal. It is a ramp signal with slope 1. That's why this is R of t. It increases at the rate of 1. Slope equal to 1. This R of t. R of t. What is u of t 2 minus t? For that, let us write this way. U of 2 minus t can also be written as u of minus t plus 2. This can also be written as u of minus 1 is taken outside, t minus 2. So this minus 1 indicates that, this minus indicates that time reversal. Time reversal. This -1 indicates a delay. So time, what is u of t? U of t is this. This is u of t. U of t. 0 t u of t. Minus infinity to 0. This is u of minus t we got. First we have to find u of minus t. This is equal to u of minus t. So time reversal. First we have to apply time reversal, then delay. Delay of -2. Delay of -2 means we had to add 2 with the time. Minus infinity plus 2 equal to minus infinity. There is no change in the initial. Finally, it ends at 0. 0 plus 2 equal to 2. Therefore, it will end at 2. Therefore, the signal is like this. It will end at 2. 0 is here. 0 is here. We have to multiply. U of t has to be multiplied by R of t has to be multiplied by U of 2 minus t. This is U of 2 minus t. That is also equal to U of minus t minus 2. So this and this we have to multiply. So we'll draw both together. If you draw in the same graph sheet, what you will get? This is R of t. This is R of t. This will coincide. This is 1. This is also width of 2, no? Okay. So what you will get up to 2 you will get. So if you multiply these two, so what you will get? Up to 2, 1. Up to 2, 1. After that 0. This signal. Here also 0. Therefore, the magnitude of 1 is multiplied by R of t. That's why it will be available up to this point. Up to this point. This is R of t. R of t. This is 1 is available up to 2. Therefore, the final signal is, after that, here U of t is 0. That's why it won't appear. That's why the final signal is a triangular pulse. Its maximum amplitude is 2. That's all. That's all. The triangular pulse of width 2, height 2. That's all. Pi of minus 0.5 t plus 2. So we have to find this. For that, this is time scaling. Time scaling. And this is delay or advancement. That let us see first. Pi of minus 0.5, let us take outside. It means if we take 0.5 out and minus 2, divide and multiply by 0.5, you will get 4. 4 into 0.5 is 2. That's all. So this minus sign indicates time scaling. Time scaling. And this is delay. Delay. Therefore, if you do time scaling, time reversal means 0.5, 0.5. Time reversal means you will get the same mirror image of this goes to this side and this goes this side. That's all. So there won't be any change at all. But if you multiply times, reversal is done. If you do the time scale of 0.5, what you will get is divide by 0.5. That's why we have to write this is y of t. Y of t equal to. So now we have to write y of t. Y of t equal to y of, what are the coordinates available? Minus 0.5 equal to y of plus 0.5 divided by, what is the time scale? 0.5. So divided by 0.5. Divided by 0.5. That is y of minus 1. This is also y of 1 equal to x of pi of we have to draw pi of minus 0.5 t we have to draw. So what if 0.5 of 1 is 0.5, therefore minus 0.5 you will get. So that is also equal to pi of 0.5 multiplied by 1, again point. The signal we got minus 0.5 t means you will get 1 to 1. 1 to 1. 4 means it will shift 3 on. So this is width of 2, therefore starts at here it starts at -1 means here it starts at 3, end at 6, 5, end at 5. So with these two, this is the answer. Express the following as function of singularity functions. Singularity functions are del of t, u of t, r of t, unit parabolic function p of t, and signum functions. Signum function are singularity functions. We have to express this signal as function of singularity. We know that its area equal to 2 is mentioned here. The area of each spike is 2. So if you draw like this is nothing but impulse. Impulse del of t. Here it is at 4 means del of t, a delayed impulse, del of t minus 4. This is del of t minus 3, delayed impulse. This is del of t. So this can be written as x1 of t can be written as starts etc. plus del of t. This is del of t plus 1, del of t plus 1 advanced plus del of t plus del of t minus 1 plus del of t minus 2 plus del of t minus 3 plus del of t minus 4 plus etc. If you write this as summation, then sum of del of t minus k, as k varies from minus infinity to plus infinity. So this is now we expressed the given signal as sum of singularities. But the problem here is the area is 2, it is mentioned. We know that the integral of minus infinity to plus infinity del of t dt equal to 1. This 1 represents the area of that impulse function. Here, area equal to 2. That's why this integration is equal to 2. So if for each impulse, area is 2. That's why we can take 2 outside. So this is that. Next one is the given signal is it linearly increases initially at the slope is 1. Slope equal to 1 because at 1 the magnitude also 1. When time equal to 1, magnitude also 1, therefore slope equal. Then suddenly it comes down to minus 1. Suddenly it comes down to minus 1. Again it linearly increases up to 2. Here also the slope is this is width 1, this is also 1, therefore slope equal to 1. How to write this? It is linearly increases means this represents a ramp signal R of t. R of t. This is also R of t. This is also R of t. If you switch from 1 to minus 1, if you add a magnitude of minus 2 to this ramp signal, it will be switched from 1 to minus 2. Suddenly we have to add some step value of minus 2 to that ramp signal. It will be switched from here to plus 1 to minus 1. Therefore, the first part can be represented as R of t. Therefore, x2 of t the given x2 of t equal to r of t. So what you will get there, we'll draw the signal. R of t means it go on increases like this. Its slope is 1. Its slope is 1. At 1, it should go here at -1. Therefore, at this point, we have to add -2 to that value. That's why we have to add -2 u of t minus whose magnitude is -2. Its magnitude is -2. This is minus 2 u of t minus 1. So if you add that, it suddenly switches from this ramp signal, this part goes off after 1 and suddenly it goes here and increases like this. So the signal now becomes it will go like this. But after this, there is no signal given. From this onwards, we have to remove this part. Remove that. What is the slope? Slope equal to again -1. Therefore, if you add another signal whose magnitude is negative, the same slope -1. This is the slope is 1. This is slope is 1. If you add a slope of -1 to this slope of -1, if you add to that, it becomes 0. So we have to add a ramp signal r of t minus. At this point, the time is 2. So delay of 2, whose magnitude should be unity, but minus. Therefore, minus r of t r of minus r of t minus 2. If you add that, it becomes nullified. That's all. Therefore, this is a singularity function. This is another singularity function. This is also a singularity function. That's why we wrote the given signal as sum of singularity function. That is x2 of t equal to r of t. This is r of t. This is the signal r of t. Minus, this is -2 u of t minus 1. From this point onwards, it's not required. That's why we have to add another signal whose slope is -1. So minus r of t minus 2. That's all. x3 of t is given. Here, it's initially unity slope is increasing like this. This is what r of t. That's why x3 of t consists of r of t. Okay. But at this point, the slope is reversed to -1. Reversed to -1. This is 1, 2, -1. This is slope equal to -1. Here, the slope is equal to 1. So at this point, it has to decrease. That's why positive slope is 1. The negative slope, the signal has negative slope of -1. To cancel this, and it has to decrease in the negative direction, means you have to add yes negative slope signal whose slope should be 2. So 2 times r of t minus 1. If you add this here, it means what? Here we are adding a slope is -2 r t minus 1 is added. That's why it starts decreasing up to 3. At 3, again it starts increasing, means this signal should be cancelled at 3. Therefore, plus 2 r of t minus 3. So here again it starts, this signal alone is there. R of t alone is there. Here its slope is unity. R of t, its slope is unity. Unity, slope is 3. That's why it increases. But here it becomes 0. After that, no signal. After that, no signal here. That's why we have to add a signal. Its magnitude is slope is 1, but the magnitude is negative. Minus R of t has to be added. That's why after 4 you won't get any signal. That's why minus R of t minus 4. R of t minus 4. A delayed ramp signal. That's all. So if you add all together, you will get this signal. R of t minus 2 R of t minus 1 plus 2 R of t minus 3 minus R of t minus 4. So this is the answer. Equal to 1. Therefore, x4 of t consists of R of t. That's all. At this point, it becomes 0. Suddenly it becomes 0. Suddenly it becomes 0 means um, we have to add minus R of t minus 1. If you add, what will happen? This will be getting cancelled. These two getting cancelled. This and this getting cancelled. And it becomes 0 like this. So to make this is also equal to 0, we have to add a step signal up. Otherwise, it will be like this. So if you add, I will draw so that you can understand. X4 of t equal to R of t minus R of t minus 1. If you put, what will happen? Two signals will get. One R of t will go like this. Here, this is R of t minus 1 minus R of t minus 1. This is R of t. If you add these two together, here its magnitude is 0. Here its magnitude is 1. 1 minus 0 is 1. That's why hereafter it will be like this. So the signal will be like this hereafter. So to make this is also equal to 0, we have to subtract minus u of t minus 1. So if you add all together, or if you add all these three signals together, what you will get is that one triangular pulse you will get. This is R of t. To cancel this minus R of t minus 1. This is R of t minus 1 minus R of t minus 1. But here it will go like this. To shift this to 0, minus u of t minus 1. If you add all together, you will get this signal. Again, there is a delay, same signal, but a delay of 2 seconds. So add a delay of 2 seconds to this, add a delay of 2 seconds to this signal, you will get second. A delay of 4 seconds, if you add, you will get the this signal. So we can write x4 of t as x4 of t equal to R of t minus R of t minus 1 minus u of t minus 1. This is for first vowel. Now for second, delayed with 2 seconds. That's why plus R of t minus 2, delayed by 2 seconds. R of t minus 3 minus u of t minus 3. That's all. Plus the third signal, delay of 4 seconds of first one. So R of t minus 4 minus R of 1. So R of minus R of t minus 5 minus u of t minus 5. Third is over. If it continues, then etc. That's all. So here up to 2, we will get a u of t. That's why xy of t equal to xy of t equal to u of t. If you put like this, it will continue like this. Continue like this. To remove this, if you add minus u of t to that, it becomes like this. But here it is not like this. Again, further it decreases to minus 1. So we have to step down by 2 magnitude. Therefore, minus 2 u of t minus 2. Therefore, the signal starts here. It will continue up to 4. It has to continue up to 4. After that, again we have to get to this. So because of this, we shifted the signal to negative. Again, if you add that, what will happen? 2u of t minus 4. If you add that, again signal will be coming like this. Again it becomes positive because u of t is still there. Now again at 6, it has to go down and go like this. So again we have to add 2 minus, we have to add minus 2 times u of t minus 6. So it should continue only up to 2, 4, 6. Here it must be 8. Here it must be 10. Because 2, 4, 6 means it must be 8. So what we have to write? At 8, we have to remove this part. So 2 times u of t minus 8. This is removed. Again, u of t is coming. Again at 10, again we need the negative part. So t minus 10. And at 12, again we have to cancel the t minus 12. So plus etc. You do like that, you will get a square wave. But here we added all unit step functions, delayed unit step function to get the square wave. That's all. Classification of signals. Signals can be further classified as continuous time, discrete time signals, deterministic and random signals, periodic and aperiodic signals, even and odd signals, energy and power signals, causal and non-causal signals. We'll see one by one. Continuous and discrete time signals. We know that a continuous signal is available at any time we require. Any point of time the signal is available, the value is available. That is called a continuous time signal. This is example, a sinusoidal signal, example for continuous time signal. On the other hand, discrete time signal means sampled signal. It is available at periodically. It is available. Its values are available periodically. So these are all discrete time signal. These values are available at a sampling instant only. So this is called discrete time signal. These are all already we have discussed all these things. Anyhow, for classification purpose, this is this. Next one is the deterministic and random signal. Deterministic signal means it can be represented by mathematical equation. It can be represented by mathematical equation. For example, this signal can be represented as A sine omega t. Like that, it can be represented mathematically. So on the other hand, a random signal means it cannot be represented by mathematical equation. We cannot represent this by mathematical equation. It's not possible. Such signals are called random signals. Random noise we used to see in electronic circuits random noise. How the noise is generated? We know that the voltage across any resistor is a function of its resistance and current through it. Function of resistance as well as current through it. If but resistance is not constant. Resistance is again the function of temperature. We know that room temperature means we used to say room temperature 20 degrees centigrade means and you cannot, it will not be a constant value. It will oscillate about 20. It will oscillate like this. This is 20 degrees centigrade scale. About that, it will oscillate like this because so many factors. So it will vibrate about, the temperature will be like this. It will vibrate about 20 degrees centigrade. It means what? The resistance is, the resistance value is vibrating. The resistance value is vibrating because the resistance is function of temperature. That's why this voltage across that resistor is vibrate. This is the way by which the noise is generated in the electronic circuit. If any resistor is there in the circuit means automatically noise will be generated because the resistance is function of temperature. Periodic and aperiodic signals. A signal is said to be periodic if it repeats its pattern periodically. Here, the signal repeats its pattern in a period of t seconds. Every t seconds, it repeats its pattern. That's why it is a periodic signal. Here, this is discrete time periodic signal. Here, also, at every fourth sample, the pattern is repeated. Pattern is repeated. Here, n, periodicity is n. Here, periodicity is t. Here, n equal to 4 samples. Every four sample, it repeats its pattern. This is also periodic. Periodic discrete time. Periodic discrete time signal. The condition for x of t to be periodic is x of t must be equal to x of t plus t, where t is the periodicity. What is the condition? X of t must be equal to x of t plus t. There must be a t for which x of t must be equal to x of t plus t. For example, let x of t equal to a sine omega naught t plus theta. In that case, x of t plus t equal to what? A sine omega naught t plus t. T is replaced by t plus theta. That is equal to x of t plus t equal to a sine omega naught t plus theta. X of t equal to what? X of t equal to a sine omega naught t plus theta. Let it be 1, let it be 2. 1 and 2 will be equal if omega naught t equal to 0 or 2 pi. Therefore, omega naught equal to 2 pi divided by t, or t equal to 2 pi by omega naught. If time period or periodicity of the signal is 2 pi by omega naught, then the signal is said to be periodic. X of t equal to e power j omega naught t. In that case, x of t plus t equal to e power j omega naught t plus t. If 1 and 2 are equal, then the signal is said to be periodic. In that case, this is also equal to e power j omega naught t multiplied by e power j omega naught capital T. Capital T. So this 1 and 2 will be equal if e power j omega naught t equal to 1. This will be equal to 1 if this omega naught t equal to 2 pi r 0. 2 pi. Therefore, t equal to 2 pi by omega naught. If it is a discrete time signal, what is the condition? Here, you notice that this is x of n. It will repeat for every n sample. Every n sample, it repeats. In this case, n equal to 4. So what is the condition? Let us assume that x of n equal to a sine omega naught n plus theta. So it must be equal to x of n plus n. That is equal to a sine. N is replaced by n plus n plus theta. Or that is also equal to a sine omega naught n plus omega naught n plus theta. 1 and 2 will be equal if omega naught n equal to 0 or 2 pi integral multiple of 2 pi because sampled system. So fractional value will not work out. So integral multiple of it must be an integral multiple of 2 pi n or n equal to 2 pi divided by omega naught multiplied by m. For the smallest value of m, n is the fundamental period. Fundamental period for the smallest possible value of m. And what is the condition for the signal to be periodic? Omega naught equal to 2 pi multiplied by m by n. M by n must be a rational number because m must be an integer, n must be an integer. That's why it must be a rational number. M by n must be a rational. If omega naught can be written as 2 pi multiplied by a rational number, then the signal is said to be periodic. M by, in other words, the condition for periodicity is m by n must be a rational number. Otherwise, a period. Even and odd signals. Another name for even signal is symmetry. This is the odd signal is called anti-symmetry. Anti-symmetry signal. The signal is said to be even if x of minus t equal to x of t for all values of t, then for all values of t, then the signal is said to be even or symmetric signal. If we take a signal like this, it is cos omega t, a cos omega t. It is an even signal. It is an even signal because it satisfies this condition. So x of minus t equal to x of t. If you for all negative values also it gives positive value. Negative values of time also it gives positive value. That's why it's even signal or symmetry. The signal is symmetry. On the other hand, anti-symmetry signal means this is anti-symmetry. A sine omega t. Here, if you put the same condition, x of minus t equal to minus x of t, you will get for all values of t. This is, if this condition is persist, then it is called anti-symmetry. Signal is said to be anti-symmetry or odd signal. Here, one thing you can notice that the even signal or symmetry signal is it is mirror image about y-axis. We see the left hand side and right hand side. One is the mirror image of the other side. But if you see the anti-symmetry, it is not so. It is 180-degree out of phase. If you see the mirror image means it will be looking like this. So this is the mirror image. If you see this, this is 180-degree phase shift. That's why x of minus t equal to minus x of t. That's odd signal. But any signal can be represented as sum of even signal and odd signal, x of odd signal. Any signal can be separated into even part and odd part. If you add these two together, you will get the original signal. But if we know the property that x of minus t, we substitute, even becomes same x of t only. But this becomes minus x odd of t, you will get. This is second equation. If you add these two together, if you add these two together, we'll get 2 times x of even of t equal to x of t plus x of minus t. Or x even of t can be found by 1 by 2 times x of t plus x of minus t. In the same way, we can find order also. If we subtract 2 from 1, we'll get x of t minus x of minus t equal to 2 times x of odd t or x odd of t. Odd part of the given signal equal to 1 by 2 times x of t minus x of minus t. So from this, we can get the odd part of a given signal. On the other hand, if it is a discrete time signal, in that case, x of n or x of k equal to x of minus n equal to x of n, then the signal is said to be even. If x of minus n equal to minus x of n, then the signal is said to be odd. For discrete case, here also we can find the same way that odd signal and even signal by using the same expression. We can prove that x even of n equal to 1 by 2 times x of n plus x of minus n. The same way we can find that x odd of n equal to 1 by 2 times x of n minus x of minus n. So this way we can find the odd part and even part of discrete time signals. Energy and power signal. Energy and power signal. Consider a circuit. Its resistance is R. Current through this circuit. Power equal to what? Power equal to I square R. That is power. What is energy? Energy is integral of energy equal to integral of minus t to plus t I square t r I square t dt. If r equal to 1, then power is I square t. The energy signal is, if r equal to 1, then it is, so if you see the limiting, if it t tends to infinity, limit t tends to infinity, integral of minus t to plus t, r equal to 1, I square t dt. That is the energy. Its unit is joules. Here, its unit is watts. Average power P equal to energy signal is product of time and power. So if you divide this by time, again you will get average. That is 1 by 2t integral of minus t to plus t is length of 2t. That's why divide by 2t I square t dt. And this is so many watts. This is average power. So these two are used to represent power and energy signals. So energy signal is in general represented by limit t tends to infinity, integral of minus t to plus t I square t dt. That is, instead of I, we can put x of t, x square of t dt. This is energy signal. The unit is joules. On the other hand, power means how to represent. Limit again t tends to infinity, 1 by 2t integral of minus t2 plus t x square of t dt. X square of t dt. This is in watts, this is power signal. Here, how to find whether the given signal is energy signal or power signal. If it is a energy signal, then in that case, power equal to 0. And the energy value lies in between 0 and infinity. It has a defined value of, E has a defined value of, between 0 and infinity, a finite value. It should have a finite value and t equal to 0. If you find the average power, it is 0. Then the signal is said to be energy signal. Energy signal. On the other hand, if P has some finite value between 0 and infinity, then energy equal to infinity. Energy equal to infinity. In that case, the signal is said to be power signal. Power signal. If this gives a finite value, the power signal has a finite value and the energy equal to infinity, then the signal is said to be power signal. How to represent these signals in discrete form? The energy signal is represented by integration is replaced by summation. N equal to minus infinity to plus infinity modulus of x of n whole square. Discrete case, power signal is P equal to limit n tends to infinity 1 by 2n plus 1 sigma n equal to minus n to plus n modulus of x of n whole square. Capital N tends to infinity 1 by 2n plus 1. Why this plus 1? Because here minus 1 to 0 from 0 to n. If you add 0th value, then you will get total number of values 2n plus 1. So to get average, we have to divide by time in the case of integration. Here divide by number of samples. So 1 by 2n plus 1. Divide, you will get power. So this is for discrete expression for discrete signals. Energy and power signal. That's all. Causal and non-causal signals. A signal is said to be causal. A signal is x of t is said to be a causal signal if x of t equal to 0 for t less than 0, then the signal is said to be causal. For all negative values of t, the signal value is the magnitude of the signal is 0, then the signal is said to be causal. Otherwise, non-causal. A signal x of t is said to be anti-causal means it is x of t equal to 0 for t greater than 0. For all positive values of time, the signal is 0 means then the signal is said to be anti-causal. Anti-causal. If it doesn't satisfy the first condition, then the system is then the signal is said to be non-causal. Non-causal signal. Similarly, for a discrete signal, x of n equal to 0 for n is less than t, less than 0. For n is less than 0, then the signal is said to be causal. X of n equal to 0 for n greater than 0 means said to be anti-causal. All practical signals are causal signals. Find the fundamental period of the following continuous time signals. The given signal is j e power j pi t. What is the standard form of the exponential signal? E power j omega naught t. Therefore, if you compare with the standard form, you will get omega naught equal to 5. Omega naught equal to 5. Therefore, time period equal to 2 pi divided by omega naught that we know. Therefore, 2 pi divided by omega naught, that is 5, equal to 0.4 pi. That's all. This is the time period of this given signal. Find the time period of the given signal sin 50 pi t. If you compare this with standard signal, omega naught equal to 50 pi. Omega naught equal to 50 pi. Therefore, time period t equal to 2 pi divided by 50 pi. Pi getting cancelled, 2 by 50 or 4 by 100. 0.04 seconds. 0.04 seconds. Find the time period of the given signal. This is the given signal. If you compare with the standard signal, omega naught equal to 10 pi. But we know that time period t equal to 2 pi divided by omega naught. That is equal to 2 pi divided by 10 pi. That is equal to pi getting cancelled. Therefore, 0.2 seconds. 0.2 seconds. Time period equal to 0.2 seconds. That's all. find whether the following signals are periodic or not. Here, notice that the two signals are added. We know that the first one is periodic, second one also periodic. We know that. If you add these two, whether they are periodic or not, how to find? For that, suppose the period of the first signal is T1, let us assume, and the period of second signal is T2. Then, if T1 by T2 or T2 by T1 equal to a rational number, then the signal is said to be periodic. Otherwise, aperiodic. So to find whether it is periodic or not, we have to find T1 and T2. What is T1? T1 equal to 2 pi divided by omega naught 1. Omega naught here, omega naught 1 equal to 10. Therefore, we get 2 pi divided by 10. What is T2? Here, omega naught 2 equal to 4. Therefore, T2 equal to 2 pi divided by 4. Therefore, T1 by T2 equal to 2 pi by 10 multiplied by 4 by 2 pi. 2 pi getting cancelled. 4 by 10 or 2 by 5. It is a rational number. It is a rational number. So, any number that can be written as a ratio of two integer means that is a rational number. If you divide that, it should be a terminating one or repeating one. And if it is infinitely long, non-repeating means then it is irrational. Otherwise, it is rational. This is the rational number only. 2 by 5 is rational number only. That's why the given signal is periodic. That the given signal, sum of two signals, is sum of here, sum of two signals is given, whether it is periodic or not. T1 equal to 2 pi divided by omega naught 1, that is equal to omega naught 1 equal to 60 pi. Therefore, 2 pi divided by 60 pi, that is equal to 2 by 60. 2 by 60. T2 equal to what? 2 pi divided by omega naught 2. That is equal to 2 pi divided by 50 pi. That is equal to 2 by 50. Therefore, we have to find the ratio of these two time periods. T1 by T2 equal to 2 by 60 multiplied by 50 divided by 2 getting cancelled. That is equal to 5 by 6. 5 by 6 is rational number. Therefore, the given signal is, given sum of signals is periodic. The third one is sum of two signals. One is periodic, we know. Another one is aperiodic. This is aperiodic. What is that signal? 2u of t. 2u of t is up to infinity. It goes up to infinity. So constant value. That is 2u of t. That is aperiodic. It won't repeat. It is aperiodic. This is periodic. If you add these two, what will happen? What is the second signal? 2 sine omega t. 2 sine omega t. Its magnitude is 2. Here minus 2. So this is sinusoidal signal. If you add these two, there will be a shift. Here the signal will be as such. Here the signal will be as such. But here there will be shift. It goes to 4. There will be shift the right hand side. So it is not periodic. if you shift by 2 pi, the values are not equal. By looking at the signal, we can say that it is aperiodic. Here, two signals are added together. You have to find a T1, time period of first signal and time period of second signal. If T1 by T2 is rational number, then it is periodic. Let us check. Here omega naught 1 equal to 4. Here omega naught 2 equal to 2 pi. Therefore, T1 equal to 2 pi divided by 4. That is equal to 2 pi by pi by 2. That is 1. T2 equal to what? 2 pi divided by 2 pi. That is equal to 1. So, therefore, T1 by T2 equal to pi by 2. Pi is irrational number. Irrational number. It is its value goes on up to infinity, never repeating infinity fraction. That's why it is irrational number. That's why it is aperiodic. Aperiodic signal. Actually, we are putting pi equal to 22 by 7 is approximate value. This is rational. That's why don't think that pi is rational. Pi is irrational number. Here, this is approximately equal to pi, not exactly. This is approximately equal to pi. Pi is a irrational number. That's why the signal is aperiodic. U of t minus 1 by 2. Sum of 1 and half. This is u of t. Here magnitude is 1. This is u of t plus 1 by 2. Minus 1 by 2. We have to add minus 1 by 2. So minus 0.5. This is 1 by 2. Minus 1 by 2. So if you add these two, what you will get is the right hand side minus 0.5 plus 0.5, you will get plus 0.5. The negative side, this is 0. Here minus 0.5. If you add these two together, you will get minus 0.5. So this is minus 0.5, here plus 0.5. This is aperiodic only. Aperiodic signal. If you add these two, this is the signal. The negative side minus 0.5, positive side plus 5. That's why it is aperiodic signal. Sine square t, whether it is periodic or not. Periodic. To check this, whether it is periodic or not, let us convert this into 1 minus cos 2t divided by 2. This is equal to 1 minus cos 2t divided by 2. What is the signal? This is also equal to 1 by 2 minus 1 by 2 cos 2t. So 1 by 2 is both-sided signal. 1 by 2. 1 by 2 on both sides. Okay. 1 by 2 cos minus 1 by 2 cos 2t is looking like this. This is minus 1 by 2 cos 2t. Now, if you add these two together, what will happen? Because of this 1 by 2, there will be a shift in that cos signal. That's why the signal will be looking like this. This is 1 minus cos 2t divided by 2. That is equal to sine square t. Sine square t. This is periodic only. This is periodic one. What is the period? Period equal to 2 pi divided by omega naught equal to 2. Therefore, 2 pi divided by 2 equal to pi. The period of this signal is pi. Condition for discrete time sinusoidal signal to be periodic. Let us assume that x of n equal to a sine omega naught n, a sine omega naught n plus theta. If x of n equal to x of n plus n, where n is a smallest integer, smallest possible integer. Anyhow, n is an integer, smallest possible integer. That is the periodicity, repeating periodicity of n. If x of n plus x of n plus n are equal, then the signal is said to be periodic. So now let us find x of n plus n equal to a sine omega n plus omega naught n plus omega naught n plus theta. These two are equal. 1 and 2 are equal when omega naught n equal to 2 pi m, where m is an integer. These two are equal means then the signal is said to be periodic. Then what is n? How to find n? How to find that frequency omega naught equal to 2 pi m by n. Omega naught is fixed because that is the frequency of that discrete signal. That must be equal to 2 pi multiplied by m by n. M is an integer, n also the integer of periodicity. If m by n is rational, then the given signal is periodic. So when it is periodic, if x of n equal to x of n plus n, then that frequency of the signal must be equal to 2 pi m by n, and m by n must be a rational number. Then the signal is said to be periodic. That's all. Find whether the following are periodic or not. The given signal is a discrete time signal x of n equal to this. We know that x of n will be periodic if x of n equal to x of n plus n, where n is the period of the signal. And also we know that omega naught equal to 2 pi m by n. This is fixed, given. In this case, omega naught equal to 0.1 pi. 0.1 pi. Omega naught equal to 0.1 pi in this case. We know that omega naught equal to 2 pi multiplied by m by n. If m by n is rational, then m by n is rational, where n is periodicity of the signal. M is an integer. In that case, m by n is rational. Then the given signal is periodic. Omega naught equal to 2 pi into m by n. In other words, m by n equal to omega naught divided by 2 pi. If this is rational, then the given signal is periodic. Therefore, we know that omega naught equal to 0.1 pi divided by 2 pi. That is m by n. That is equal to 0.1 divided by 2, or 1 by 20 is a rational number. That's why the given signal is periodic. What is the period n of that signal? How to find n? N, we know that n equal to, from this we can write n equal to 2 pi m divided by omega naught. That is equal to 2 pi m divided by omega naught equal to 0.1 pi. Pi getting cancelled. Therefore, 20 m. For n should be smallest, m must be equal to 1. M must be equal to 1. Therefore, n equal to 20 is the period of the cycle. Period n equal to 20 is the period of the cycle. That's all. Given that x of n equal to e power j 6 pi n, this is given. Here, omega naught equal to 6 pi. It is given. It is fixed. We know that omega naught equal to 2 pi multiplied by n, m divided by n, or m divided by n equal to omega naught divided by 2 pi. That is equal to omega naught equal to 6 pi divided by 2 pi. That is equal to 6 pi 2 equal to 3. 3 by 1 is rational number. That's why the given signal is periodic. What is the period? We know that n equal to 2 pi m divided by omega naught. That is equal to 2 pi m divided by omega naught equal to 6 pi. Pi getting cancelled. Therefore, m divided by 3. N will be the smallest integer when m equal to 3. Therefore, n equal to 1 is the periodicity of the signal. The smallest value of n is when m equal to 3. The smallest value of n as integer. It must be an integer. N must be an integer. For n to be the smallest integer, m must be 3. For that, n equal to 1. Therefore, period of the signal is n equal to 1. Sine, the given signal is sine 6 pi n divided by 7. Therefore, omega naught equal to 6 pi divided by 7. We know that omega naught equal to 2 pi m by n. M by n must be rational for the signal to be periodic. In other words, omega naught divided by 2 pi equal to m by n. That is equal to 6 pi divided by 7 multiplied by 2 pi. Pi getting cancelled. Therefore, 3 by 7 is rational number. Therefore, the given signal is periodic. What is the value of n? Period n equal to 2 pi m divided by omega naught. That is equal to 2 pi m divided by 6 pi by 7. Pi getting cancelled. Therefore, 14 by 6 or 7 by 3 m. If m equal to 3, if m equal to 3, n will get a smallest integer. Therefore, n equal to 7 is the period of the signal. In continuous domain, we have seen if two signals are added together, then and if T1 is period of first signal and T2 is the period of second signal, if T1 by T2 is rational number, then the given signal is sum of signal is periodic. In the same way, here we have to find n1 and n2. If n1 by n2 is rational, where n1 is the period of the first signal, first discrete signal, second discrete signal, period of second discrete signal, the ratio is rational number, then the given signal is given sum of signal is periodic. Sum of signals is periodic. So what is N1? To find N1, first let us check whether the first one is periodic or not. For that, omega naught 1 equal to 2 pi by 3, that we know. Therefore, omega naught 1 divided by 2 pi equal to m by m1 divided by n1 equal to omega naught 1 equal to what? 3 pi divided by 3 multiplied by 2 pi. 2 pi by 3. Omega naught equal to 2 pi by 3 multiplied by 2 pi. 2 pi getting cancelled, therefore 1 by 3 is a rational number. Is rational number. Therefore, first signal is periodic. Here n equal to what? N1 equal to 2 pi m1 divided by omega naught 1. That is equal to 2 pi m1 divided by omega naught 1 equal to 2 pi divided by 3. That is equal to 3 m1. When m1 equal to 1, n1 will get a smallest integer. Therefore, period of the first signal is 3. N1 equal to 3. That is the smallest value of N1. That is period of the signal. In the same way, let us find the period of the second signal. N2. First, let us check whether the given signal is period or not. Just for we know it is period. That's anyhow. Let us check. Omega naught 2 divided by 2 pi equal to m2 divided by n2 equal to omega naught 2 is 3 pi by 4 multiplied by 2 pi. Pi getting cancelled. That is 3 by 8. Yes, 3 by 8 is a rational number because 3 by 8 equal to 0.375 terminating decimal. That's why it is a rational number. Therefore, it is periodic. Second signal also periodic. What is the value of N2? Period of N2 equal to 2 pi m2 divided by omega naught 2. That is equal to 2 pi m2 divided by omega naught 2 is what? 3 pi by 4. 3 pi by 4. Pi getting cancelled. Therefore, 8 by 3 m2. When m2 equal to 3, n2 is the smallest integer. Therefore, n2 equal to 8. When m2 equal to 3. Therefore, we got n1 equal to what? N1 equal to 3 we got. N2 equal to 8 we got. N2 equal to 8 we got. N1 equal to 3 we got. Therefore, N1 by N2 equal to what? N1 by N2 equal to 3 by 8. Is a rational number. Is a rational number. Therefore, given signal is the sum of the signals. Given sum of signal is periodic. Periodic. That's all. Now let us move on to next sum. Here, omega naught equal to 3 pi. Omega naught equal to 3 pi. We know that omega naught divided by 2 pi equal to m by n equal to 3 pi divided by 2 pi equal to 3 by 2. That is rational number. Rational number. Hence, the given signal is periodic. Given signal is periodic. What is the value of n? N equal to 2 pi m divided by omega naught. That is equal to 2 pi m divided by omega naught equal to what? 3 pi is to getting cancelled. 2 by 3 m we got. N equal to an smallest integer when m equal to 3. Therefore, n equal to 2. N equal to 2. This is the period of the given signal. Period of the given signal. X of n equal to 12 cos 20n. find whether the given signal is period or not. To check that, let us find omega naught. Omega naught equal to 20. Omega naught equal to 20. We know that omega naught equal to 2 pi multiplied by m by n. If m by n is a rational number, then it is periodic. In other words, omega naught divided by 2 pi equal to m by n is rational number or not, we have to find. Omega naught equal to what? 20 divided by 2 pi. That is equal to 10 by pi is not a rational number. Pi is not a rational number. Not a rational number. We used to say that pi equal to 22 pi n. This is approximately 22 by 7 is a rational number. But pi is infinitely non-repeating decimal. That's why it is not rational. Pi is not a rational number. It involves pi. That's why it is not a rational number. Therefore, the given signal is not periodic. A period, not period. A period. Cos 1 by 4n omega naught equal to 2 pi m by n, where m by n, if m by n is a rational number, then it is m by n is rational number, then the given signal is period. But what is omega naught? Omega naught equal to, in this signal, omega naught equal to 1 by 4. 1 by 4. Therefore, 1 by 4 multiplied by 2 pi, that is equal to 1 by 8 pi. 1 by 8 pi is not a rational number. It is not a rational number. Therefore, it is not periodic. It is a periodic. A periodic signal. Determine the power and RMS value of the signal x of t equal to a cos omega naught t plus theta. The power of a signal equal to limit t tends to infinity 1 by 2t integral of minus t to plus t x square of t dt. Therefore, this is equal to limit t tends to infinity 1 by 2t integral of minus t to plus t a square cos square omega naught t plus theta dt. This is also equal to, we know that cos square theta equal to 1 plus cos 2 theta divided by 2. So if you substitute that, you will get limit t tends to infinity. A square is constant, that's why we can take outside. 2t integral of minus t to plus t. Cos square is 1 plus cos 2 omega naught t plus theta dt divided by 2. That is also equal to limit t tends to infinity a square divided by 4t. The 2 is taken outside. This can be separated into two integrals, minus t to t of dt plus integral of minus t to plus t cos 2 omega naught t plus theta to dt. As the integration is from minus 2t plus t, this becomes 0. This is equal to 0. This is equal to 0. That's why this is equal to limit t tends to infinity a square divided by 4p. If we integrate dt, t, if we substitute the limit, it becomes t plus t. That is 2t. That is equal to limit t tends to infinity a square divided by 4t multiplied by 2t. T getting cancelled. Therefore, a square divided by 2. What is the RMS value? Now let us find the RMS value of this. The RMS value equal to square root of power 6. That is equal to square root of a square divided by 2. A divided by root. A divided by root 2. RMS. From this, we can conclude that power equal to, here, what is the magnitude? Amplitude of the signal is A. Therefore, power equal to amplitude square divided by 2. We can directly write. Similarly, RMS value equal to square root of A square divided by 2, that is equal to A divided by root 2. Determine the power and the RMS value of the following signal. We know that power equal to amplitude of sinusoidal or cosine signal square divided by 2, and RMS value square root of p, that we know. From this, here the amplitude is 5. Therefore, power equal to 5 square divided by 2. Therefore, 25 divided by 2 equal to 12.5. RMS value equal to square root of 12.5. RMS value. That's all. Find the, determine the power and RMS value of the following signal. Here, two signals are summed. That's why we have to find the P1 and P2, and we have to add these two together. Therefore, P1 equal to what? 10 square amplitude square divided by 2 plus P2 equal to amplitude square divided by 2. That is equal to 100 divided by 2 plus 256 divided by 2. That is equal to 50 plus 128 equal to 178. Therefore, RMS value equal to square root of P, that is equal to square root of 178. Determine the power and RMS value of the following signal. Here, x of t equal to 10 cos 5t plus cos 10t. If they are in terms of sum, we can solve it, but it is not in sum. That's why we will find, we will convert this into sum of the signal. That is equal to cos A cos B equal to 1 by 2 cos A plus B plus cos A minus B. Here, A equal to 10 and B equal to 5. Therefore, this is equal to 1 by 2 cos 15t plus cos 5t. Here, the amplitude here is common. Therefore, 10 divided by 2. That is equal to 5 cos 15t plus 5 cos 5t. Therefore, this is equal to 25 divided by 2 plus 25 power equal to P1 plus P2. P1 equal to 5 square, 25 divided by 2 plus 25 divided by 2, 25. Therefore, RMS value equal to square root of 25 equal to 5. Determine the power and RMS value of the given signal. We know that power equal to limit t tends to infinity 1 by 2t integral of minus t to plus t x of t x square of t dt. This can also be written as limit t tends to infinity 1 by 2t integral of minus t to plus t modulus of x of t whole square dt. That is equal to integral of limit t tends to infinity 1 by 2t integral of minus t to plus t modulus of e power j alpha t cos omega naught t whole square dt. This is equal to limit t tends to infinity 1 by 2t integral of minus t to plus t modulus of e power j alpha t multiplied by modulus of cos omega naught t whole square dt. That is equal to limit t tends to infinity 1 by 2t integral of minus t to plus t e modulus of e power j alpha t equal to 1. Therefore, 1 multiplied by cos omega naught t. We know that cos theta equal to 1 plus cos 2, cos square theta equal to 1 plus cos 2 theta divided by 2. T tends to infinity 1 by 2t integral of e power j alpha t equal to 1 modulus of e power j alpha t equal to 1. Therefore, 1 square multiplied by cos square omega naught t can be written as 1 plus cos 2 omega naught t divided by 2 multiplied by dt. Limit minus t to plus t. This can be written as limit t tends to infinity 1 by 2t integral of minus t to plus t. This 1 can be separated into dt plus this cos 2 omega naught t can be written separately minus t to plus t cos 2 omega naught t dt. This 1 by 2 can be taken outside and instead of 2t we can write 4t. So this is equal to limit t tends to infinity 1 by 4t. This is equal to 0. Integral of minus t to plus t cos 2 omega t equal to 0. That's why if we integrate dt, you will get t. T, the limit is minus t to plus t plus 0. That is equal to, this is equal to 2t. Therefore, limit t tends to infinity 1 by 4t upper limit t minus of minus plus t, therefore 2t, t getting cancelled. That's why 1 by 2. Therefore, power equal to 1 by 2. Therefore, RMS value equal to square root of 1 by 2, that is equal to 1 by root 2. Determine the power and RMS value of the given signal. We know that power equal to limit t tends to infinity 1 by 2t integral of minus t to plus t x of t whole square dt. This can also be written as limit t tends to infinity 1 by 2t integral of minus t to plus t modulus of x of t whole square dt. This is equal to limit t tends to infinity 1 by 2t integral of minus 2t plus t x of t equal to a e power j omega naught t. Therefore, it can be written as modulus of a e power j omega naught t whole square dt. If you take this constant a outside, you will get a square divided by 2. Limit t tends to infinity a square divided by 2t integral of minus t to plus t e power modulus of e power j omega naught t whole square dt. Modulus of e power j omega t equal to 1. Therefore, this can be written as limit t tends to infinity a square divided by 2t integral of minus t to plus t dt. That is equal to limit t tends to infinity a square divided by 2t. If you integrate this, you will get t minus t to plus t is the limit. That is equal to limit t tends to infinity a square divided by 2t. This is equal to t plus t. That is equal to limit t tends to infinity a square divided by 2t 2t getting cancelled. That's why a square is the answer. A square is the answer. Power equal to a square. Therefore, RMS value equal to square root of a square equal to a. That's all. Sketch the following signals and calculate the energies. The signal is e power minus 10t and multiplied by u of t means right-sided signal. Because of this multiplication, what is u of t? U of t is this up to infinity. Magnitude is 1. So if you multiply with any signal, the signal becomes right-sided. Okay. So now let us find the energy. E equal to what? E equal to limit t tends to infinity minus t to plus t modulus of x of t whole square dt. That is equal to limit t tends to infinity integral of minus t to plus t. Here e power minus 10t u of t whole square dt. So if you, because of this u of t, if you remove that, the limit becomes right-sided signal. That's why this minus t becomes 0. Therefore, we can remove this u of t and we'll change the integration limit from 0 to t. Therefore, this becomes limit t tends to infinity integral of minus t to plus t, 0 to t e power minus 20t. If you square, it becomes 20t. 20t dt. That is equal to, if you integrate this part, you will get limit t tends to infinity 1 by minus 1 by 20 e power minus 20t 0 to t. If you substitute 0, e power 0 equal to 1 upper limit. For lower limit, it becomes minus limit t tends to infinity. For upper limit, it is minus 1 by 20 e power minus 20t minus minus plus 1 by 20 e power 0 equal to 1. If t tends to infinity, this becomes 0. That's why this is equal to 1 by 20 alone. Therefore, energy equal to 1 by 20. Sketch the following signal, then calculate the energy. We didn't plot the signal. If we plot the signal, because for u of t we plot. For e power minus 10t, it will be like this. It goes to 0 at infinity. At infinity, it becomes 0. This magnitude becomes 0. Here e power 0 equal to 1. Therefore, it starts at 1. It exponentially decreases. At infinity, it becomes 0. This is signal. If you multiply these two, already this is right-sided signal. So nothing will happen. It will be the same. Okay. Energy equal to 1 by 2. Sketch the signal and then find the energy. U of t minus u of t minus 15. This is u of t. This is u of t signal. It goes up to infinity. Magnitude is 1, it goes up to infinity. U of t minus 15. T minus 15 means a delayed signal. Delayed signal, it starts at 15. This is also u of t minus 15. If you subtract 2 from 1, what you will get after this 15, this both are 1. 1 minus 1, 0. That's why after 15, no signal. That's why the resultant signal will be like this. 1 to 15 seconds, the magnitude will be 1. This is the resultant signal. This is u of t minus u of t minus 15. Now we have to find the energy. Energy equal to what? E equal to limit t tends to infinity, integral of minus t to plus t x of t whole square dt. That is equal to limit t tends to infinity. Here, there is no signal after 15. It starts at 0, ends at 15. That's why the limit becomes 0 to 15. And its magnitude is 1. Its magnitude is 1. Therefore, 1 square dt. If you integrate this, you will get limit t tends to infinity. T you will get. If you integrate, you will get t, limit is 0 to 15. That is equal to limit t tends to infinity. 15 minus 0, that is equal to 15. It is independent of t, that's why only 15. 15 is the energy. Energy equal to 15. That's all. Cos 2 pi t u of t, u of 2 minus t. Cos 2 pi t u of t u of 2 minus t. So u of t is it is a unit magnitude signal up to infinity. U of 2 minus t can be written as u of minus of t minus 2. This minus 2 indicates time reversal. This minus sign indicates delay. Time reversal is the signal becomes like this, minus infinity to 0. That is u of minus t. If you introduce a delay of 2 seconds, it becomes, we have to introduce in the starting, that is minus infinity plus 2 equal to minus infinity. Starting point is same. End point is 0. 0 plus 2 equal to 2. That's why end point shifted to 2. Therefore, the signal is starts at infinity, end at 2. This is u of 2 minus t. If you multiply this first signal and the second signal, you will get a pulse, because after 2, second signal is 0. Before 0, first signal is 0. Therefore, you will get a magnitude of 1 up to 2 only. What is cos 2 pi t? Cos 2 pi t is a signal spread on both sides. This is cos 2 pi t. If it is cos 2 pi means time period is 1 second. That's why during that 2 second, it will complete 2 cycles. 2 cycles. If it is 2 pi means, cos 4 pi means, 4 pi t means time period equal to t equal to 4 pi divided by 2 pi equal to 2 seconds. Therefore, time period is 2 seconds. Therefore, in 2 seconds, it will complete, in 2 seconds, it will complete only one cycle. This is cos 4 pi t. The same 2 seconds, it will complete only one cycle. Here, this will complete 2 cycles. Which one? Cos 2 pi t will complete 2 cycles. That is the difference. Now, let us find the energy. If you multiply these two, cos signal will be truncated after 2 before 0. So, we have to find the energy for this cos signal. That's all. We have to find energy for this. What is the formula for energy? Limit t tends to infinity, integral of minus t to plus t, cos 2 pi t u of t, u of 2 minus t dt whole square. This is energy. But because of this u of 2 minus t, the signal is limited from 0 to 2 only. That's why we can change the integration from 0 to 2. That's why there is no meaning of limit t tends to infinity, because it becomes independent of t. Therefore, the energy equal to integral of 0 to 2 cos 2 pi t dt whole square. Therefore, cos square 2 pi t. We know that cos square theta equal to 1 plus cos 2 theta divided by 2. That's why this can be written as integral of 0 to 2 cos square 2 pi becomes 1 plus 4 pi t cos 4 pi t divided by 2 dt. That is equal to integral of 0 to 2 1 plus cos 4 pi t divided by 2 dt. This is equal to 1 by 2 integral of 0 to dt plus 1 by 2, second part, this second part. Second part, 1 by 2, if we take outside, 0 to 2 cos 4 pi t dt. Up to 2, the cos 4 pi will complete only one cycle. This becomes 0. How? If you integrate one complete cycle, we will get one of positive half cycle and negative half cycle. If you add these two together, it will be 0. Therefore, for one complete cycle, the integral of cos 4 pi t equal to 0. So this 1 by 2 integral of 0 to 2 dt alone is there. That's why energy equal to 1 by 2 integral of dt from 0 to 2. That is equal to 1 by 2 dt means t 0 to 2. That is 2 by 2 equal to 1 joule. Therefore, the answer is 1 joule. That's all. Which of the following are energy signals? Let us investigate whether the given signal is energy signal or power signal. Now let us investigate. U of t minus u of t minus 1. U of t is what? This is up to infinity. This is u of t. U of t minus 1 means delayed by 1 second. Delayed by 1 second. U of t minus 1. Delayed by 1 second. So if you multiply these, if you subtract second from the first, after 1 second, both are 1. It becomes 0. That's why the resultant signal is magnitude of 1 up to 1 only. Let us find the energy. Energy equal to what? Limit t tends to infinity, integral of minus t to plus t x of t whole square dt. Here the signal is limited up to 1 only. Therefore, we can change the limit of the signal from instead of t0, instead of minus t0, instead of t1. That's why this becomes independent of t. That's why limit also can be removed. Therefore, integral of 0 to 1, x of t equal to 1. It is a magnitude of 1 up to 1. Therefore, 1 square x of t becomes 1 square dt. That's why this is equal to 1 square. If you integrate 1, you will get t. So t from 0 to 1, that is equal to 1 minus 0, that is equal to 1 joule. What is power? This is energy, is 1 joule. What is power? Power equal to limit t tends to infinity, 1 by 2t integral of 0 to 1 dt. That is equal to what? Therefore, limit t tends to infinity, 1 by 2t. This becomes 1. As t tends to infinity, it becomes 0. Therefore, energy equal to 1 joule, power equal to 0. Therefore, the given signal is energy signal. If energy equal to definite value, and power equal to 0 means it is energy signal. If energy equal to infinity and power a definite value, then it is a power signal. What is R of t? R of t is go on increases up to infinity it goes. Time also infinity. Its slope is 1. Minus R of t is what? Minus R of t is this way. Here also slope equal to 1. Slope equal to minus 1. Minus R of t means. That's all. If you add these two, you will get to 0. But R of t has a delay of 2 seconds. That's why what happens here is R of t starts here. Minus R of t is with a delay of 2 seconds. This is r of t minus 2 minus r of t minus 2. If you add these two together, because the given signal is sum of r of t and r of t minus 2, both the slopes are 1. Slope equal to 1. Here slope equal to minus 1. What will happen after this? Up to 2, it will increase. That's all. Up to 2, you will get this. After this, it increases at the rate of 1. It decreases at the rate of 1. So here its value is, at this point its value is 1. At this point its value is 0. 1 minus 0 is 1. So 1. After another 1 second, if you see, here the value is 2. Its value is 2. Here its value is 1. Therefore 2 minus 1, again 2. Again 1. 2 minus 1 equal to 1. That's why after that it remains 1. Therefore, the final signal is looking like this. Initially it is r of t. After that it remains 1. From 2 onwards it remains 1. So what is energy signal? Energy equal to integral of 0 to 2 0 to 2 r of t whole square dt plus from 2 to infinity, its magnitude is 1 dt. 1 dt. That's all. Because after that it is 1 only. So what you will get, this is equal to the average, the energy signal equal to r of t equal to t. Therefore, integral of 0 to 2 to infinity, we have to, energy signal means we have to include one more thing. E equal to limit t tends to infinity, that we have to include. So here 2 to t we have to write. Here we have to write up to t. So 0 to limit t tends to infinity, E equal to t tends to infinity. R of t is t square dt, because it's the equation, equation of R of t is t. 0 to 2 plus limit t tends to infinity, integral of 2 to t dt. That is equal to, if you integrate this, t cube limit t tends to infinity, t cube divided by 3, t cube divided by 3, limit is 0 to 2, first integration. Second part, what is second part? Second part is this. Second part is this. Limit t tends to infinity, integral of dt becomes t, limit is 0 to t. That's why what you will get is, here you will get, it is independent of t, that's why no problem. T cube means 2 cube equal to 8 by 3 plus limit t tends to infinity, t minus 0. That's why as t tends to infinity, the sum is infinity. Therefore, energy equal to infinity. Now let us check what is power. What is power? Now let us find the power for this. Power equal to what? Power equal to limit t tends to infinity, 1 by 2t, integral of 0 to 2 t dt, t square dt, plus limit t tends to infinity, 1 by 2t, integral of 2 to t, 1 square dt. That is equal to this is independent of t, that's why we can, sorry, here also 2t is there. Here what you will get, limit t tends to infinity, 1 by 2t. Here, if you integrate this, you will get, already we got 8 by 3, 8 by 3, 8 by 3 plus limit t tends to infinity, t tends to infinity, 1 by 2t. Here you will get t, t, because the integration is t minus 0 t. Here t getting cancelled, 1 by 2. Here, as t tends to infinity, this becomes 0. This becomes 0. This becomes 0. This is equal to 1 by 2. Therefore, power equal to 1 by 2 watts. So, power equal to 1 by 2 watts, energy equal to infinity. Therefore, the given signal is power signal. The given signal is power signal. The energy equal to infinity and the power equal to 1 by 2. That's why the given signal is power signal. 1 plus e power minus 5t. What is 1? 1 means both side its value is magnitude is 1. Both side. Here minus t minus infinity to plus infinity, its magnitude is 1. That is 1. That is 1. E power minus 5t is how it looks like. It will be like this is e power 1 here, e power minus 5t. It is multiplied by u of t, means both are right-sided signals. That's why this 1 also left hand side getting cancelled. Only right hand side. This is also right hand side. That's why what is the energy? E equal to limit t tends to infinity, integral of minus t to plus t, 1 plus e power minus 5t whole square u of t dt. Since you multiply by u of t, the energy signal becomes limit t tends to infinity, integral of minus t, instead of minus t, it becomes 0, because we are going to remove u of t. We are going to remove u of t. In place of u of t, we are changing the limit from 0 to t. 1 plus e power minus 5t whole square dt. That is equal to limit t tends to infinity, integral of 0 to t, a plus b whole square equal to a square plus 2ab, 2 e power minus 5t plus b square. B square means e power minus 10t. I multiplied by dt. So what you will get is 3 integrations you will get. Limit t tends to infinity. The 3 integrations, what you will get? Integral of 1. That's why t minus 0 you will get. T minus 0 for the first integration. Second integration, if you integrate this divided by minus 5, you will get e power minus 5t. 2 you can take outside, divided by minus 5, e power minus 5t. Limit is from 0 to t. Plus, for this you will get 1 by minus 10. Minus 1 by 10. E power minus 10t. Limit is 0 to t. What you will get? This is equal to limit t tends to infinity. You will get t here plus 2 times. For upper limit and upper limit, you will get e power minus 5t. For lower limit, you will get 1. E power 0 equal to 1. Similarly, for second part also, for upper limit, you will get e power minus 10t minus, for lower limit, you will get 1. That's all. If t tends to infinity, this becomes infinity, plus 2 times e power infinity minus infinity is 0 minus 1. plus here this becomes, as t tends to infinity, this becomes 0. This also becomes 0. That's why plus 0 minus 1. 1 infinity is there. Whatever may be the other values, you will get infinity. Therefore, energy equal to infinity. What will happen to power? Power means the same result, but you have to multiply by 1 by 2t. Therefore, power equal to limit t tends to infinity 1 by 2t t plus 2 into e power, as t tends to infinity, it becomes 0, e power minus 5t minus 1 plus e power minus 10t minus 1. We'll divide inside by 2t. T getting cancelled. You will get 1 by 2 for the first term. Anything divided by infinity is 0 plus 0. Therefore, power equal to 1 by 2 watts. Power equal to 1 by 2 watts and the energy equal to infinity means it is a power signal. It is a power signal. Find which of the following signals are energy signals. Power signal, neither energy nor power signals. You have to find. It is given that x of t equal to e power minus 3 t multiplied by u of t. Any signal multiplied by u of t means it is the right side. What is energy? E equal to limit t tends to infinity integral of minus t2 plus t e power minus 3t u of t whole square multiplied by dt. Here, this u of t indicates that it is right side signal. That's why this minus t can be replaced by 0. Therefore, this integration becomes limit t tends to infinity integral of 0 to t e power minus 3t dt whole square. That's why it is 60 e power minus 60. Limit t tends to infinity 1 by minus 6 e power minus 6t. Limit is from 0 to t. If you substitute this, what you will get is limit t tends to infinity minus 1 by 6 upper limit e power minus 6t minus, for lower limit you will get minus of minus plus 1 by 6 multiplied by 1. As t tends to infinity, this becomes 0. This becomes 0. Therefore, the answer is E equal to 1 by 6. It is independent of t. That's why there is no need for limit 1 by 6 joules. Energy we got. What is power? Power equal to limit t tends to infinity 1 by 2t minus 1 by 6 also can be taken outside. E power minus 6t minus 1. As t tends to infinity, this becomes 0. Therefore, this is equal to limit t tends to infinity 1 by 12 t equal to 0. 1 by 12 t equal to 0. Therefore, power equal to 0, energy equal to 1 by 6. Therefore, the given power equal to 0, energy has some definite value. Therefore, the given signal is energy signal. Energy signal. Find whether the given signal is energy signal or power signal. We would find it. Let E equal to limit t tends to infinity, integral of minus t to plus t, modulus of e power j 2t plus pi by 4 whole square dt. We know that modulus of e power j 2t plus pi by 4 equal to 1. That's why this can be written as limit t tends to infinity, integral of minus t to plus t, modulus of 1 whole square dt. That is equal to, if you integrate dt, you will get t limit t tends to infinity, t limit is minus t to plus t. That is equal to limit t tends to infinity 2t as t tends to infinity. This is equal to infinity. Therefore, energy equal to infinity. What is power? Power equal to what? Power equal to limit t tends to infinity 1 by 2t. That is the difference. Minus t to plus t modulus of e power j 2t plus 5 by 4 whole square dt. So integration is same. That's why limit t tends to infinity 1 by 2t, 2t, 2t getting cancelled. The integral value is equal to 2t. Already we got here. That's why we can substitute that. 2t getting cancelled. Therefore, equal to 1 watts. So energy equal to infinity, power equal to 1 watts. Therefore, given signal is power signal. If energy equal to definite value and power equal to 0 means is energy signal. Here energy equal to infinity, power equal to a definite value. That's why this is a power signal. The given signal x of t equal to cos t. Find whether the signal is energy signal or power signal or neither energy nor power signal. We have to find. For that, let us first check what is the energy of this. E equal to limit t tends to infinity, integral of minus t to plus t cos square t dt. This is equal to limit t tends to infinity, integral of minus t to plus t. Cos square t can be written as 1 plus cos 2t divided by 2 multiplied by dt. This is equal to limit t tends to infinity, integral of minus t to plus t. This can be separated into two integrals. This part one integral and this part another integral. So 1 by 2 dt plus limit t tends to infinity, integral of minus t to plus t 1 by 2 multiplied by cos 2t dt. Integral of cos 2t dt from minus t to plus t is equal to 0. Therefore, this becomes limit t tends to infinity 1 by 2 t minus t to plus t, that is 2t. Therefore, limit t tends to infinity 1 by 2 2t. As t tends to infinity, energy becomes infinity. What is power? Power equal to limit t tends to infinity 1 by 2t comes into picture additionally. And what is the integral value? Integral value is 1 by 2. Already we did 1 by 2, 2t. 1 by 2 multiplied by 2t. 2 getting cancelled. T also getting cancelled. Therefore, there is no meaning of t tends to infinity because it becomes independent of t. That's why that is equal to 1 by 2. T equal to 1 by 2 watts. Here, energy equal to infinity. Energy equal to infinity. Power equal to 1 by 2 watts. Therefore, the given signal is power signal. The given signal is discrete time signal x of n equal x of n equal. Therefore, energy equal to integration becomes summation. Limit n tends to infinity. Sum of n equal to minus n to plus n 1 by 3 to the power n u of n. U of n is a right-sided signal. That's why this minus n becomes 0. Therefore, this can be written as limit n tends to infinity sigma n equal to 0 to n 1 by 3 to the power whole square. Therefore, 3 square becomes 9. Therefore, 1 by 9 to the power n. 1 by 9 to the power n. N tends to infinity. N equal to 0 to infinity of 1 by 9 to the power n. This is less than 1. 1 by 9 is less than 1. We know that sigma n equal to 0 to infinity a to the power n equal to 1 by 1 minus a, as a is less than 1, provided a is less than 1. Therefore, here a is less than 1. Therefore, the value is 1 by 1 minus 1 by 9. That is equal to 9 minus 1. That is 9 by 8. Now let us find power. Power equal to limit n tends to infinity 1 by 2n plus 1 sigma n equal to 0. Why 0? Because of this un. Because of this un. N equal to 0 to capital N. 1 by 9. Already we 1 by 3 whole square. That's why 1 by 9 to the power n. So here summation is not up to infinity. It is up to n. In that case, the formula is limit n tends to infinity 1 by 2n plus 1. 1 minus 1 by 9 to the power n plus 1 divided by 1 minus 1 by 9. 1 minus a. The formula is, if you sum up to n, then the formula is 1 minus a to the power n plus 1 divided by 1 minus a, where a is less than. So in that case, 1 minus 1 by 9 to the power n plus 1. As n tends to infinity, 1 by infinity multiplied by 9 by 8, that is equal to 0. That is equal to, this part is, as n tends to infinity, this part is equal to 9 by 8. This part is equal to 0, 1 by infinity. That is 0 multiplied by 9 by 8 equal to 0. Therefore, energy equal to finite value, 9 by 8 joules, and power equal to 0 watts. Therefore, the given signal is energy signal. Given signal x of n is a discrete time signal. We have to find whether the given signal is energy signal or power signal. Let us check whether the given signal is energy signal or not. Energy equal to what? For discrete time, limit n tends to infinity, sigma n, small n equal to minus n to n. X of n whole square. That is equal to modulus of x of n whole square. Therefore, limit n tends to infinity, sigma n equal to minus n to n modulus of x of n, that is modulus of e power j pi by 2n plus pi by 8 whole square. But this modulus of e power j theta equal to 1. Therefore, this is equal to limit n tends to infinity, sigma n equal to minus n to n 1 square. If you add 1 from minus n to plus n, you will get limit n tends to infinity 2n plus 1. As n tends to infinity, this is equal to infinity. Therefore, energy equal to infinity. What is power? Now let us check the power. Power equal to limit n tends to infinity 1 by 2n plus 1 sigma n equal to minus n to n modulus of x of n whole square. Already we proved that modulus of e power this is equal to 2n plus 1. Already we got 2n plus 1. Therefore, limit n tends to infinity 1 by 2n plus 1 multiplied by 2n plus 1. 2n plus 1 getting cancelled. Therefore, this is equal to 1 watts. Power equal to 1 watts. Energy equal to infinity. Therefore, the given signal is power signal. Power signal. The given signal x of n is a discrete time signal. We have to find whether the given signal is energy signal or time signal. Sorry, we have to find whether the given signal is energy signal or power signal. Let us check whether the given signal is energy signal or not. Energy equal to what? For discrete time, limit n tends to infinity, sigma n small n equal to minus n to n x of n whole square, that is equal to modulus of x of n whole square. Therefore, limit n tends to infinity, sigma n equal to minus n to n modulus of x of n, that is modulus of e power j pi by 2n plus pi by 8 whole square. But this modulus of e power j theta equal to 1. Therefore, this is equal to limit n tends to infinity, sigma n equal to minus n to n 1 square. If you add 1 from minus n to plus n, you will get limit n tends to infinity 2n plus 1. As n tends to infinity, this is equal to infinity. Therefore, energy equal to infinity. What is power? Now let us check the power. Power equal to limit n tends to infinity 1 by 2n plus 1 sigma n equal to minus n to n modulus of x of n whole square. Already we proved that modulus of e power this is equal to 2n plus 1. Already we got 2n plus 1. Therefore, limit n tends to infinity 1 by 2n plus 1 multiplied by 2n plus 1. 2n plus 1 getting cancelled. Therefore, this is equal to 1 watts. Power equal to 1 watts. Energy equal to infinity. Therefore, the given signal is power signal. Power signal. Given is x of n. It is a discrete time signal. Check whether the signal is power signal or energy signal. Let us check first the energy signal. Energy equal to limit n tends to infinity, sigma n n equal to minus n to plus n cos pi by 4n whole square. But we know that cos square theta equal to 1 plus cos 2 theta divided by 2. Therefore, this can be written as limit n tends to infinity sigma n equal to minus n to plus n cos square equal to 1 plus 1 plus cos 2 pi by 4 equal to pi by 2 n divided by 2. That is equal to limit n tends to infinity sigma n equal to minus n to plus n. 1 by 2 can be taken outside. Summation of 1 plus another part. What is that another part? This is another part. If you write for that limit n tends to infinity 1 by 2 sigma n equal to minus n to plus n cos pi by 2 n. But the summation tends to 0 if you sum from minus n to plus n of cos pi by 2 n. Therefore, this is equal to limit n tends to infinity 1 by 2. If you sum 1 for minus n to plus n, you will get 2n plus 1. As n tends to infinity, this becomes infinity. So energy equal to infinity. What is power? Now let us check the power. Power equal to limit n tends to infinity 1 by 2n plus 1 sigma n equal to minus n equal to minus n to plus n cos pi by 4 n whole square. That is equal to, already we proved that this is equal to 2n plus 1 by 2 multiplied by 2n plus 1. Therefore, this can be replaced by limit n tends to infinity 1 by 2n plus 1 multiplied by 1 by 2 2n plus 1. This step is replaced here. Therefore, 2n plus 1 getting cancelled. 1 by 2 alone is there. Therefore, no need for limit. Therefore, it is equal to 1 by 2 watts. Therefore, power is 1 by 2 watts. And power equal to 1 by 2 watts. Power is definite, 1 by 2 watts. Energy equal to infinity. Therefore, it is a power signal. It's a power signal. Determine the energy and power of the following signals. X of t equal to t u of t. First, let us find the energy. E equal to limit t tends to infinity, integral of minus t to plus t, x of t, x square of t dt. That is equal to limit t tends to infinity, integral of minus t to plus t, x square, that is t square, u of t square dt. U of t means right-sided signal. If you multiply a signal by u of t, it means it is a right-sided signal. Therefore, the limit is changed from minus t to 0. Minus t to 0. Therefore, 0 to t, t square dt. U of t is removed. In place of that, minus t is replaced by 0. That is equal to limit t tends to infinity, t cube divided by 3. Limit is from 0 to t. That is equal to limit t tends to infinity, t cube divided by 3 minus 0 as t tends to infinity, the result is infinity. Therefore, E equal to infinity. Let us check the power. Power equal to limit t tends to infinity 1 by 2t integral of minus t to plus t x of t square dt. That is equal to limit t tends to infinity 1 by 2t. This integral value is already we got. T cube divided by 3 already we got. Therefore, this is t cube divided by 3. T cube becomes t square because of this t. That is equal to limit t tends to infinity t square divided by 6. As t tends to infinity, the result is tends to infinity. Therefore, power also equal to infinity. Therefore, the given signal is neither energy signal nor power signal. Neither energy nor power. The given signal is x of n equal to 2 e power j 3 pi n. It is a discrete time signal and a complex signal. Complex signal. Energy E equal to limit n tends to infinity sigma n equal to minus n to plus n modulus of, because it is a complex signal, that's why modulus of 2e j 3 pi n whole square. If we take that 2 outside, what we will get is limit n tends to infinity sigma n equal to minus n to plus n. 4 can be taken outside, 2 square is taken outside, modulus of e power j 3 pi n. This is equal to modulus of e power j 3 pi n equal to 1. Therefore, the signal becomes limit n tends to infinity 4 times sigma n equal to minus n to plus n summation of 1. If you add the sum of 1, how many ones? 2n plus 1. 2n plus 1 ones are there. That's why the result is limit n tends to infinity 4 times 2n plus 1. 2n plus 1. As n tends to infinity, the given result becomes infinity. Therefore, energy equal to infinity. What is power? Power equal to limit n tends to infinity 1 by 2n plus 1 sigma n equal to minus n capital N modulus of 2 e power j 3 pi n whole square. We'll get the same. Already we proved this is equal to 2n plus 1 multiplied by 4. Therefore, limit n tends to infinity 1 by 2n plus 1 multiplied by 4 times 2n plus 1. So already we got 4 times 2n plus 1. Therefore, the 2n plus 1 getting cancelled. Therefore, the answer is 4. There is no meaning of limit n tends to infinity because it becomes independent of n. Therefore, power equal to 4, energy equal to infinity, and the power equal to 4. Therefore, the given signal is power signal. Power signal. Find which of the four signals are causal or non-causal. X of t is said to be causal if x of t equal to 0 for t less than 0. Then it is called causal. Otherwise, non-causal. So now let us check e power at u of t. U of t, if you multiply by u of t, means it is a right-sided signal. Right-sided signal. That's why it's x of t equal to 0 for t less than 0. Therefore, the given signal is causal. Causal. Next, e power minus 2t multiplied by u of minus t. U of minus t means this is u of minus t. U of minus t. It exists for, the value is exist for t less than 0. That's why, because this signal will exist for t less than 0, x of t is exist for t less than 0. That's why it is a non-causal. So sync t. Sync t signal is looking like this. Sync 2 signal is. This is sync t signal. For sync t signal, it exists for t less than 0. This side, both sided, two-sided signal. That's why it is non-causal. X of n equal to u of n plus 3 minus u of n minus 2. It is a discrete time signal. For a discrete time signal, x of n is said to be causal if x of n equal to 0 for n less than 0. Let us check for n is less than 0. When n equal to minus 1, what will happen? X of minus 1 equal to u of minus 1 plus 3. So 2. U of 2 minus u of minus 2 minus 1 minus 2. That is minus 3. Minus 3 is 0. This is equal to 0. But this is equal to 1. Therefore, x of minus 1 equal to 1. What is x of minus 2? X of minus 2 equal to. So now itself we can say that it is a non-causal because it exists for negative values of n. Therefore, it is non-causal. We can say. So now let us check for x of minus 2. X of minus 2 equal to x of minus 2 plus 3. That is u of 1 minus u of minus 2 minus 2 minus 4. This is equal to 0 because the index is negative. That's why it is 0. Here index is positive. U of it is a right-sided signal. That's why its value is 1. Therefore, x of minus 2 equal to 1. Therefore, x of minus 2 equal to 1. Therefore, the value exists for negative values of x n. X of minus 3 also will exist. U of 0 minus u of minus 5. This is equal to 0 because index is negative. That's why it is 0. But here it is equal to 1. That's why x of minus 3 also equal to 1. For all other negative values of n, it is 0. But anyhow, it's exists for negative values of n. Therefore, it is a non-causal. So let us see this x of n. X of n equal to 1 by 2 to the power n multiplied by u of n plus 2. Now substitute, find x of minus 1. Let us check. X of minus 1 equal to 1 by 2 to the power minus 1 u of minus 1 plus 2. That is equal to 1 by 2. This becomes 2. 2 multiplied by u of 1. So its value is equal to 1. Therefore, value equal to 2. Exists for negative values of n. Therefore, this is also non-causal. Non-causal. Let us check for x of minus 2 also. X of minus 2, we check. X of minus 2 equal to 1 by 2 to the power minus 2. U of minus 2 plus 2, that is equal to 2 to the power 2 multiplied by u of 0. This is equal to 1. Therefore, its value equal to 4. It exists for negative value. All other values, it will not exist, but two values exist. That's why it is non-causal. Consider the signal x1 of t. x1 of t. Shown in figure, plot x1 of t minus 1 plus x1 of minus 2 minus t plus 2. This is also x1. x1 of t minus 1, delayed by 1 second. Then what is the x1 of t minus 1? x1 of t minus 1 is delayed by 1 second. 4, 3, 2, 1. Delayed by 1 second. This is x of t minus 1. What is x of minus t plus 2? This can be written as x of minus of t minus 2. This minus sign indicates time reversal. Time reversal. This indicates a delay. Therefore, first we have to do the time reversal. If you do the time reversal, what we will get is x of minus t we have to find. That is x of minus t. 0, minus 1, minus 2, 0, minus 1, minus 2, minus 3. So this is x of minus t. Now we have to obtain x of time delay by 2 seconds. Where it starts at minus 3. Delay by 2 seconds means it should start at minus 1. End at 0 means it will end at 2. So therefore, it starts at time delay of 2 seconds. Time delay of 2 seconds. That's why it will start at the minus 1. End at 2. That's all. This is what this is x of minus t plus 2. So we have to add 1 and 2. If you add these two, what we will get is every point we have to add. Here, this signal alone is there. That's why you'll get the same 1, minus 1, and 0. Here, up to 1, the first signal alone. That's why same you will get. From 1, both signals are there. Its magnitude is 1. Here also its magnitude is 1. That's why up to 2, it is 2 magnitude. After 2, what will happen? This alone is there. That's why again reduced 1. 2 to 3 again 1. 3 to 4, it will decrease. So minus 1, 0, 1, 2, 3, 4. This is sum of both signals. That is x of t minus 1 plus x of
minus 2 plus minus t plus 2. This is sum of two signals. Express the signal x of t in figure in terms of step and ramp. The same question may be asked like this. Express the signal x of t in terms of singularities. What is the slope of this ramp signal? Slope equal to 1. Here after that it remains 1. From minus 2 to plus 2 it remains 1. Here again ramp slope equal to minus 1. That's all. So first to get a signal at minus 3. So at minus 3 if you draw, if you take r of t of unit slope, r of t plus 3 advanced because it starts at minus 3. Therefore, we can write x of t equal to r of t plus 3. It is advanced by 3 units of time. So you will get. But it is up to 2 only. After 2, it is 1 only. So if you include another ramp signal of slope 1, but negative slope equal to minus 1. Here, what is the difference? At minus 2, the first signal magnitude is 1. Second signal magnitude is 0. Therefore, difference is 1. At minus 1, first signal magnitude is 2. Second signal magnitude is minus 1. The difference is again 1. At 0, the first signal magnitude is 3. Second signal magnitude is minus 2. 3 minus 2 again 1. Like that, it will extend up to 2. So we are getting the signal like this. At 2, so we have to add now r of minus r of t plus 2. So at 2, the slope is minus 1. The slope is minus 1. Its slope is minus 1. Slope is minus 1. And therefore, r of t plus 3 minus r of t plus 2. So we got like this up to 2. At 2, what happens? It starts decreasing. It starts decreasing. Its slope is again minus 1. Therefore, here if you draw another r of t minus 2, delayed by 2 seconds, it starts decreasing because it's, if you add these two, 1 minus 0 is 1. Here, it is, what is its value? Its value is 1, minus 1. Minus 1. 1 minus 1, 0. After that, no signal. So, but if you leave it, what will happen? It will decrease like this. So, to cancel this, if you add one more signal like this, these two will be getting cancelled. So, if you add this signal, what is that signal? This is r of t plus minus 3, delayed by 3 seconds. So, if you add 1, 2, 3, and 4 signals together, this is the first signal, second signal, third signal, and fourth ramp signal. If you add all the 4s together, you will get the signal x of t. So what is the answer? We have to represent like 3 r of t plus 3. This is at the minus 3. At 2, r of t plus 2 minus 4. At 2, again, this is r of minus r of t minus 2. At 3, this is 2, this 1, 0. This is at 3, r of t minus 3. So if you add all the 4 signals together, all the 4 signals, 1, 2, 3, and 4. All the 4 signals together will get this signal. That's all. A continuous time signal is shown in figure. Sketch and label carefully each of the following signals. So x of t minus 1 means delay by 1 unit of time. So it actually starts at minus 2, minus 2. Now it has to delay by 1 unit of time means it should start at minus 1. 0. Again, 1. Two, 3. That's all. So the same signal delayed by 1 unit of time. This is x of t minus 1. Delay by 1 unit of time. Find the x of 2 minus t. X of t is given. Find x of 2 minus t. This can be written as x of minus of t minus 2. This minus sign indicates that time reversal. Time reversal. This minus 1 indicates delay. That's all. First, we have to find the time reversal. First, we have to find x of minus t. Then, we have to find x of minus of t minus 2. We are delay by 2 seconds. Delay by 2 seconds. Then it is called x of 2 minus t. This is also equal to x of 2 minus t. So to find that, first let us find x of minus t. Time reversal means what will happen to this signal? Right sided will become left sided. One. Left side becomes right side. That's all. This is x of minus t we got. If we delay this by 2 seconds, what you will get? It starts at minus 2. Delay by 2 seconds means minus 2 plus 2 equal to 0. So it will start at 0. Then 4, this is 3, 2, 1, 0. It ends 2 here. Delay by 2 seconds. That's why it's the ends at 4. This is x of 2 minus t. The third one is sketch the signal x of t multiplied by del of t plus 3 by 2 minus del of t minus 3 by 2. This plus indicates that advanced by 3 by 2 means 1.5 seconds. This means delay. Minus means delay. So an impulse signal advanced by 3 by 2. 3 by 2 means 1.5 minus 1.5. Advanced by 3 by 2 seconds. So minus 1.5. This is minus 3 by 2.
minus 3 by 2 from 0. So an impulse signal of magnitude 1 at minus 3 by 2. Another impulse signal is its magnitude is negative. It is at plus 3 by 2 because a delay of plus 1 point, delay of 1.5 seconds. This is minus 1. That's all. If you del of a signal multiplied by impulse means it samples at that point. What is the sampled value at that point? The signal is at that point, this here its magnitude is minus 1. Here 0. In unit time, it varies from 0 to minus 1, means in between its value is minus 0.5. Therefore, the sampled value is minus 0.5, magnitude minus 0.5. Here, the sampled value here it is 1, here it is 0, means in between it's 0.5. It's 0.5, but impulse has negative sign. That's why here the sampled value, here also minus 0.5. In both places, the sampled value is minus 0.5. At 3 by 2, its magnitude is 0.5. At minus 3 by 2, at plus 3 by 2, that is 1.5, its magnitude is minus 0.5. This is the resultant of given x of t multiplied by del of t plus 3 by 2 minus del of 3 minus t minus 3 by 2. That's all. Determine and sketch the odd and even parts of the given signal. What is even part of the given signal? Given signal is x of t. Even part of x of t equal to x of t plus x of minus t multiplied by 1 by 2. That is even part. So to find what x of t is here already available. X of minus t we have to find. So time reversal. Time reversal if you do for the given signal, time reversal, it will be like this. This is x of minus t. X of minus t. This is x of t. We have to add these two together. So if you add these two together, what is the here minus 1? Here 1, here 2. That's all. So up to 1, its slope is increasing. Slope 1. Its slope also increasing. Slope 1. Slope 1. That's why it will increase the rate of slope 2. This is 1. This is 2. This is minus 1. Minus 2. 1. 2. Okay. It increases at the rate of slope 2 because slope 1 and slope 1 are added together. That's why slope becomes 2. Okay. After that, it is constant 1, but it decreases at the rate of slope 1. Slope minus 1, it decreases. That's why it remains 1, but here it is 2. 2. If you add these two together, it remains 2. But at 2, this is 0, but this is 1. So at 2, it will reduce to 1. After that, it remains like this. This is left-sided signal. Right side, what will happen? These two are added together means it increases. This is slope 1. This is slope 1. This is also slope 1. If you add these two together, it increases at the rate of slope 2 up to 1. Then what happens? It starts decreasing, but it remains 1. It remains 1. Up to 2, it's decreasing. So it decreases. After that, it remains 1 because after that, this is 0. 2 is 0, but signal 1 is 1. That's why it remains. This is x of t plus x of minus t. But its amplitude should be multiplied by 1 by 2. That's why it is reduced like this. So what will happen? Its amplitude is 2 means 2 multiplied by 1 by 2 means it becomes 1. So 1, this is 2. It is now, the slope is reduced to 1. There is no change in time scale, but amplitude is reduced. Here it is amplitude is 1, here also amplitude 1, that is reduced to 0.5. This is 2, this is minus 2. Here it is reduced to 0.5. Here also it is reduced to 0.5, then it will be like this. Here its magnitude is 0.5. 0.5. That's all. X even part of t. That is equal to 1 by 2 times x of t plus x of minus t. That's all. Now we have to find odd part of the signal, x naught of t. That is equal to what? 1 by 2 times x of t minus x of minus t. That's all. So x of t is given. Now we have to find x of minus t. What is x of minus t? Let us draw here. X of minus t is magnitude is 1 here. Here it is 1, 2. Here it is minus 1. This is what? This is time reversal. X of minus t. Now we have to add these two signals together, x of t and minus x of minus t. So we got plus x of minus t. Now let us find minus x of minus t. This is 2, 1, 0, minus 1, minus 2. Here, let us first draw minus x of minus t. This is minus x of minus t. This is minus x of minus t in blue. Now, we have to, with that, we have to add x of t. The x of t is what? X of t, let us draw in green. This is 1. This is x of t. This is x of t. We have to add these two together to get this part. To get this part, we have to add. So we have to get x of t minus of x of minus t. That we have to obtain. Now let us draw that in red. Before minus 2, let us start from minus 3. Before minus 2, only this blue signal is there. Only blue signal. That's why we will convert blue into red. Only one signal. From minus 2 to 1, blue signal is 1, but the green signal is increasing from 0 to 1. At minus 1, green signal is 1. blue signal is 1. If you add, this is -1, this is +1, if you add these two, 0. So at -1, it is 0. Therefore, it decreases from 1 to 0. After that, here, see the slope of green signal 1. What is slope of blue signal? 1. That's why it remains 0 up to 1. Up to 1, the slope on both sides is same. That's why up to 1 it is 0 only. At 1, what happens? Blue is decreasing from -1. But green is 1. So it starts increasing. At 2, its value becomes 1. Therefore, it increases and goes to 1 at 2. After that, it remains 1. So the red part is called x of t minus x of minus t. Now we got red part. Green is x of t, blue is minus x of minus t. If you add these two together, we got the red part. Now we got that x of t minus x of minus t, but it should be multiplied by 1 by 2. It should be multiplied by 1 by 2. If you multiply this 1 by 2, what will happen? Its amplitude only. There is no change in time scale. Amplitude is reduced from 1 to the positive side 1 to 0.5. Negative side also 1 to 0.5. That's why now let us draw that red signal. Red signal redrawn. But the magnitude up to -1 to +1, 0. After that, it increases to 1. But here it will be magnitude is increased to 0.5. So it increases to 0.5 and remains. Here at -0.2, it increases to -0.5 and remains there. This is x odd of t. X odd of t equal to 1 by 2 multiplied by x of t minus x of minus t. That's all. Determine and sketch odd and even parts of given signal. The given signal is discrete time signal, x of n. For that, the even part of the signal, x even of n equal to 1 by 2 times x of n plus x of minus n. And the odd part of the signal, if we separate the odd and the even, the odd part of the signal is x of n minus x of minus n. Now let us find one by one. X of n is given. That's why we have to find x of minus n. X of minus x of n equal to at 0 the value is 3. At 0 the value is 3. At -1 2. At -2 1. Right side, if you see 6 zeros, 1 2 3 4 5 6, then 1. That's all. This is x of n. What is x of minus n? X of minus n is, you have to reverse this about 0. 3 as such. This side it becomes 1. 6 zeros, 1 2 3 4 5 and 6. This side comma 2 comma 1. That's all. So x of n plus x of minus n equal to what? X of n plus x of minus n. Corresponding elements has to be added. If you add the corresponding elements, here it is 1. Then 4 zeros. 1 2, 3, 4. Then 1 plus 0 is 1. 2 plus 0 is 2. 3 plus 3 is 6. That is the reference origin. Then 2 plus 0 plus 2 is 2. 0 plus 1 is 1. Then how many? 0, 0, 0, 0. Then 1. Seventh. 1, 2, 3, 4, 5, 6, 7. This is x of n plus x of minus n. Now we have to multiply this by 1 by 2. Therefore, x even of n equal to 1 by 2 times x of n plus x of minus n. That is equal to, if you multiply this 1 by 2, this becomes 0.5. 1, 2, 3, 4. 0.5, 1, 3, 1, 0.5, 1, 2, 3, 4, then 0.5. This is the even part of the signal. Even part of the signal. If you draw, how it looks like. Which is 0? At 0, 3. 3, 2, 1. So, at 0, 3, magnitude is 3. Magnitude is 3. At 1, 1. At 2.5. 1, 2, 3, 4, 5, 6, at 7.5. This side, again 1 at minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Here 0.5. Here 1 and 0.5. So this is x even of n. Even of n. Odd of n, how to find x of n minus x of minus n, we have to find. That is multiplied by 1 by 2. Multiplied by 1 by 2. Therefore, 1 by 2, 1 by 2, x of n minus x of minus n. 0 minus 1 is minus 1. How many zeros? 4 zeros. 0, 0, 0, 0. Then 1 minus 0 is 1. 2 minus 0 is 2. 3 minus 3 is 0. Then 0 minus 2 is minus 2. 0 minus 1 is minus 1. Then 1, 2, 3, 4, then minus 1. That's all. If you multiply this by 1 by 2, what you will get? Minus 0.5, 0, 0, 0, 4 zeros, then again 0.5, 1, 0, minus 1, minus 0.5, 0, 0, 0, minus 0.5. That's all. Now let us plot odd part of the signal. Odd part of the signal. This is x odd of n. We plot this, how it looks like. 6 and 7. Minus 0.5 at 7. Then all 0 at, this is the reference. At 2.5, word, positive. At 1, magnitude is 1. At minus, at -1, 1, -2, 0.5. At 1, n equal to 1, this negative value, -1, -1. At 2, -0.5. At 7, -0.5. This is the plot of x odd of n. That's all.